the annual average of maybe the temperature or the total sum of rainfall per year. We had also seen you do things which were related to having maybe the total sum or annual average of a year per month, of a month per year, sorry. And then I was saying also that we could also have situations where you have things maybe related to maybe the month over a period of years. So something like the climatology of a particular month. Okay, so maybe if you have like January 1991, January 1992 to maybe 2000 or 2020, 2020, you probably could kind of have the mean of all of those Januaries. Okay, maybe the mean of the total sum of rains for all those Januaries, and then they kind of give you an idea of what's the mean total sum of rainfall could be in January for a particular place. So what we are going to try to do differently today is what we call the tailored product. So tailored products, as the name comes across, is there are things which are not generalized. They are not standard for everyone. There are things which are restricted or related to a particular thing that the client or you as a researcher or the Met agency wants to have, which is unique for them. Okay. And so we are going to delve a bit into more of those kind of tailored products. One of the tailored products you probably would have seen could be what Danny had shown you yesterday with the world weather records, which are the information which WMO I here take maybe annually. Okay, and so those are just some of the basic differences here. Today, I'm going to try and show you something on tailored products like the start of rates, okay? Because it's per your definition. You need to define these tailored products so that they then fit your situation. Okay, so basically that's what we are going to do today, and I'll be the one instructing today. Roger would have to join us later within the day. So basically, to do this, I think we do not have a lot of time. There are quite a lot of things you guys want us to look at before we leave here. So I think for the rest of the workshop, we will try as much as possible to go by the what we call the parallel demonstration. Okay, so what you do as I do, okay, that kind of situation. That's what we are going to do. So we are going to use a standardized data set for this exercise. And I'll follow it up with a presentation. So we go to File, we go to Import from Library, we go to Load from Instat Collection, we browse, we go to Climatic, we go to Ghana, it's a familiar name there. We go to Ghana 2 stations type. I don't want to start the whole process. I just want to work with the tidy data. Okay. Ghana 2 stations type. And we can see, we learned from Roger last time that if we did a right click and we go to levels or labels, we can immediately see that there are 2 levels, okay, in terms of the station. You can see that there are 2 levels, which is there's Saltpond and there's Tamale, okay? And like I was telling you before, the tailored products is not a generalized, thing which go cuts across, okay? So I'm going to try and take one of the stations. I want to be specific because the climatology in Tamale is different from the climatology in Saltpond. Saltpond is bimodal, Tamale is unimodal. So if I want to define something for Tamale, it may not necessarily be the same for Saltpond. And so that's what basically we're going to do. And who can tell me how we can easily do this? I have all my data sets together. I have my sort one and Tamale all together, and I want to start working on one data set. Just filter. So could you show me what I do? Right click on the sort one. Yeah. Filter rule. Yeah. And then you select the one. Yeah, I have. Guys, please let's all be here. Okay. You're going to define you. Yeah. Okay. Select the station. Station. Good. Then I select sort one. I want to work with Tamal. Then I add. So now you do it as a subset. Great. So I'll give you a name to it. Okay. Will this work? Fingers crossed. Good. You are very good students of Roja. All right, great. So so now we have our family data set, and then we are going to start to produce the tailored products for Tamale. Sometimes you could probably use this for a set of stations if the stations tend to have something in common, okay, in terms of the definitions you probably would give, and know that the definition, like even as I've said, it's not just unique to the place. It could be unique per the farmer or per the person who wants to do that, who needs that tailored product. Somebody will say, I want the start of rains, I want to start in a different way. The other will say, so let's just go ahead. Remember that this data was already tidy, okay, and therefore it's already gone through all the tidy processes that you have here, the dates, the defined climatic, the check data. It's gone through that process, okay. And we now get to the prepare. And this was the place where we're doing some of the things on the standardized products, where we transform rainfall to rainy days, and then we could do climatic summaries on them. So now, start of the rains is an example of a tailored product, which we are going to look at. So start of the rains. We'll keep talking. Okay, so you see when I chose Tamale, it immediately puts in all the details, okay? The station name, the date name, and why is this happening? Who can tell me why this is happening? Is that the answer? We all agree that it's because we defined it as a climate, as climatic. You think so? Yes. So we all agree? Okay. So let's just check if it's really defined climatic. So how do we do this? Those ones are talking too much. You have to raise your hand if you want. I have a cane here, which can't keep the same. So who's going? Those who are saying, Madam Malikem, you said it's climatic. Where do we go? How do we know this is climatic? How do we know? We go to climatic. How do we know the data set is climatic? It's a climatic data set. It's defined as a climatic data set. Maureen? Yeah, okay. You know, there are two options here, but we just click on this one, right? Okay. And so how do we know it's climatic from here? So what is this data frame telling us? This one. What's this whole day? I'm trying to make us revise a bit some of the things we've done before, and then also do something new. So bear with me.
a summary of the column.
Summary of the column. Okay. Yes. So the bit where you are saying climatic is this one. So what's happening here?
It's telling more about the columns.
We have. Okay.
It's climatic because that's the able to tell us things about that.
Okay, good. So here, that's right. I think, yeah, you guys have been listening very well. So good. Yeah. We have stations as climatic. We have dates. So we have the station here. Okay, the station down here is climatic. The date here is climatic as well. The year is climatic. The month, April, is also climatic. The day is climatic. It's defined as a climatic intercept. So what isn't defined as climatic? We have sunshine and everything defined as climatic. Are these defined as climatic? The RH6, RH9, RH12, they are not. And that's why we have the NAs. Good. Okay, so let's just go back. And so that's why when you go to climatic, okay, and you go to prepare and you go to start of the rains, these things fill up automatically because station is climatic. And so the dialogue knows that it's going to take anything about station is going to go under station. Anything about dates is going to go under dates and all of that. Okay. And then we have the opportunity to edit these things. Okay. Okay. Good. And so this dialogue, one of the things this dialogue is trying to tell us, remember, we are trying to look at the start of the range. So we are looking at a definition. The definition we are probably getting from an extension officer or in the north of Ghana or in Tamale, saying that the start of the rain is the first two consecutive days, okay, where there's rainfall above 0.85, no, not 0.85 millimeters, above 20 millimeters, okay, that either the total, the first 2 days, when you add them up, they give you 20 millimeters or more rainfall, okay, that is when is the start of the rains. And this is after a certain time when they know that the season should be started. So in Tamale, what do we call when do we say the rain should be started? Is it in March? Is it in April? Is it in May? Dependent on what you want. So what do we do? Remember, the threshold you see here is just telling us what a rainy day is. Okay, and a rainy day needs to be more than 0.85 per default. But here, this is where we select when we should start looking for our start of the rates. So when do we start? Who works in Tamale?
Let's start from first impressions.
So
That's why I said let's start from first impressions.
So like I said,
asking the questions. That sometimes when we say let's start from knowing that the climatology is normally around April, May, and we start from March.
The reason why you don't want to start in January is if it happens that in January 15th you have 20 millimeters of rainfall. It would make it as the start of the rain, but it's a false start.
You're not really there before.
So yes. I said on 15th of January, you get 20 millimeters or more rainfall. The system will take it as a start of the rain. No, but by to sample, it's adding. Two consecutive, that's what it does.
No, I'm saying that one day, right now, and I don't satisfy the definition.
That's what the definition is 2 consecutive days. So if the first day is 15th January.
Yes.
Okay, and that is 20 millimeters. The second day is 16th January, and it's 0. 20 plus 6, 0 is how much?
They call it
As you call it, that's 0, it is
you know,
0 is below 0.
Yeah, but it's consecutive days. 0.85 is just for a rainy day.
it's a criteria for a rainy day.
day.
But Francis, it is also contingent on the number of dry days that will follow after this.
So let's take it one after the other. Okay, let's take it one after the other. The first simple start of the rains is just interested in saying how many days, there are 2 consecutive days which are 20 millimeters or more rainfall within the start of the season. Okay, that is just the rule. Okay, which of the first days which that's the simple start of the rains. Okay, so that's what we are trying to find here. Are we good?
Wait, you are defining a rainy day.
We are not defining a rainy day. What I'm telling you is that this is the rule. The definition of the start of the rains is saying that you should find, okay, within the season, 2 consecutive days, okay, which has rainfall of more than 20 millimeters of rainfall. Whether it's a rain day or no rain day, it's not concerned.
You don't have to bring that. It's not.
So what I'm saying is that if we pay attention here, okay, this is just a threshold to tell you something about rain days. There are some, that's why I said it's a tailored product. There are some how they call it, some jurisdiction where they play like the rain day is an element of your definition. In your definition, this is not an element, so it doesn't play a part in the calculation for you. Do you understand? There are some jurisdictions, for instance, if you go somewhere, how do they call it, Haiti, those places where like they have lots of rains and things like that, their definition is slightly different from that. Is why it's a tailored product. For your area, you're not concerned about this. You are concerned about the fact that how many, when I have this amount of rainfall, that's why I started by telling you that the extension officer or the farmer, guys, hello, I hope you are all paying attention. This is a useful discussion we are having here. So the farmer, I'm telling you that the extension officer or the farmer there is telling me that, oh, I need to have a lot of rain to have fallen within the season. Then I'll know that the season has started. Okay, what is a lot of rain? Or a lot of rain have fallen, and we are quantifying it by like interactions with them. We are quantifying to say, when I have about 20 millimeters of rainfall, it means I've had a lot of rain. So your definition is saying what the start of the rains is any consecutive days, 2 consecutive days that I probably would have had 20 millimeters or more rainfall, okay, to have fallen within the season, okay. And then I'll say my season would have, my start of the season would have started. So you do not concern about the 0.85. I was just showing you that the 0.85 is still that threshold which we refer as a rainy day thing. But for your definition, you do not have that in there. Okay? Is that clear?
Yeah, I understand. But for now, you said because it's a tailored product that is within the area, this one doesn't really matter.
Okay, good. So now let's agree on which time we should show. Maureen, we are interested in your discussions. Yeah, otherwise we are likely to have very false starts. Okay. Okay, but so we should look for something closer to the season. Like we said, it's a tailored. So what you want is what we do. Okay, so what do you want? Tell us what you
So, truth of the matter is,
so I'll just tell you.
If indeed your climatology shows that rains normally don't start in January, it will skip it. Because the data itself will not even have the data to meet this criteria. So it is separated to move on.
I don't think it's skip. Then what is here? Yeah, it will pick it.
That is why, because this is training, maybe you are restricting ourselves to this stuff. But in defining the onset, there are other conditions attached to it.
So this is the simple start.
This one is the
simple start of the rings.
You can define it. Yeah, January to February last year. Then after that,
there's a dry period.
In 2001, and it will just be as straight as it started.
But then that is why in defining the other conditions that will tie in and you see that it's a process.
So I'll just do the simple one now. So for Pixar, we've used before, I think we did either April or May. One of them. April. Okay. And so that's going to be sorry? Okay. So yeah. Yeah, it doesn't really matter now because you're already, it's going to be in the season, right? So it's for the year, right? So okay, good. So as you can see, it's kind of selected day of the year greater or equal to 92, or day of the year less or equal to 366. Okay. And so the total rainfall over 2 days, and then the amount being 20 limited. Okay. Total rainfall over 2 days. Here, this is where your number of dry days, of rainy days thing comes in here. So if you check this, then this will start working. Also answer. Yeah, good. So here, in our case, we don't really concern about the number of rainy days. Yeah. Okay, good. And then we go, okay. Error. There's this error. Let's call that out. What's that? It's funny. There's this error coming. Just a minute, I'm trying this surprising. Let's check it. Let me just restart it, reset it and see. Have you seen that error before? Derek.
No.
Did you guys try the same thing? Did you have this?
Yeah.
The same error come up? Let's try this. I'm Sally. Are you on? Have you ever come across this error before?
Hello, Francis. Yes, I'm trying and I'm getting the same error.
Sorry.
Yes, I'm trying as you try and I got the same error.
You don't. It's a front message.
Hello,
Yes. Sorry.
can you hear me?
Yes, I can. What do you say?
Yeah. No, I was saying
You're
I'm
also
doing
getting
what
an
you are
error?
doing.
Yeah.
Yes, I'm getting the same error that you get.
Okay. Just try this and see. I'm
Yes,
Sally.
Francis.
Okay.
Yes.
So
Yes.
like I explained, we go to climatic, we go to prepare, we go to start of the race. And then, Sammy, please. And then we can see that automatically the receivers are filled with the climatic variables. Okay. And you then come here to select your day range. Okay, which is, we said April to December is our range. Then we return. Like I said, the threshold, you can always change it if you are going to use something on rainy days. If you probably want to say a rainy day should be 20 millimeters or whatever, or 1 millimeter, you can change it here. But it doesn't affect your definition unless you want to choose number of rainy days. Then that comes in. So here in our definition, it says consecutive rainfall of 20 millimeters starting after 1st of April. You should find any day within 1st of April and 31st December of every year to find the day, the first time we have 20 millimeters or more rainfall. That is what people would say simply. It means the rain season has started. Okay, so that is what we have taken over here. And then we just go here. So basically, when you do the day of year, it will give you the number, the Julian number, the number of that start date. Okay, when you do the date, it gives you the what we call it, the rain start date. So the date in itself. So in 1944, whatever. Okay, I think the occurrence. Let's try that and see. I haven't really tried that, but let's see. It's really not too important. It's just telling us whether it's rained or not. So I'll take that out. Good. So basically, we can see we have a new data set that has been generated. I'm using the 0.7 for the earlier version of this, of the 0.75 to demonstrate this. It's just a bug, and they keep working on it. So that will be improved, and a new one will be uploaded on the site. So I think no, it will remain the same one. I think that's correct. And then after here, I'll probably show you if you find bugs, how you can report on it, and that helps with those developing. They can go back and then look at some of the things because they don't get the time to try everything at once. They keep trying. So you can see now, Tamale 1944, start of the rains day was, the Julian year was 109, and that is 18th April, okay, in 1944. In 1945, it was 9th April, down. So from 1940 to 2016 to the date. So when you come back here, you should see a date, something by date. And you have to check that. When you check it, it should come. So basically, this is the start of the rain. I may uncheck that even so that I can do the comparison with the new one. Okay. Something like that. Bear with me, I'm just deleting this. So I don't want stats. I just want to have the Julian rate and then good. And then, so basically, this is just a simple start of the rate without any dry spell condition. You remember that Ghana Kofi was mentioning that if we want to use the January one, maybe the dry spell thing could pick it up. I safely wouldn't also still do that anyway. Just I know there's been conversation about why are we not starting before, because if it's very robust, it should be able to note that in January, when it rains, there's going to be a dry spell. And then what if it doesn't? The question is, what if it doesn't? There's also another rate that overcomes that dry spell thing. So you safely, there is another definition which we call the start of rains with dry spell condition. And it's the same process. You go into the everything, that's the 2 consecutive days with 20 millimeters of more rainfall within the April to 31st December period. But this time around, you come to check the dry spell condition, okay? And you are saying that after it finds that 20 millimeters of rainfall, which he says that, well, it has rained here, it should go on further, because there are sometimes you get false starts even within the season period. So he says that after you found the start, continue within the next about 21 days, that's the next 3 weeks. So let's say somebody said, well, the rains have started, so I'm going to plant my beans or tomatoes or whatever. And then he plants, and then for the next 3 weeks, he or she doesn't have rainfall. There's a likelihood the seed will die or the seedling won't grow. So we try to then say that within the next 21 days, you should ensure that there is no 10 consecutive days, okay, where there's no rainfall, okay, within that 21 days. Does that make sense? Yeah. After the 21 days, it should, because at that time, probably the crop would have been a bit like more grown or something, and we would be able to resist a bit some of these things. Dry. It ignores the first start. So after that 9 consecutive days, it says, no, this is not my start. Then it starts again. So it finds one, and then it checks the next 21 days. Are there consecutive dry days? And yeah, so basically that's, and so normally we say this is for one who is a risk-averse farmer, a farmer who is like, but sure say with my main trainer. But there are people who are like the game boys, the game people. They are like, I have to take your, because remember, the more you delay into the season, the shorter the length of your season also becomes. And so if your crop also doesn't get its normal length to go, it also becomes another issue for you. Good. So we'll try that one. The same process, and just go, okay. I made a mistake. It has overrated. So let me do this again. Uncheck this. Okay, this is the normal stats. Okay, I'll just rename it. Okay. Remember, if you are using these columns, you just need to rename it so that you really don't get things overwritten, because they tend to use the same name in statement. So I'll call it normal stats. Okay, and then I'll do the new one. Like I said, when the bag is fixed, you should be able to do this in your in your 0.75. The new downloaded one means you probably need to download, or if it's an easy thing, they probably will show you how you could use your old one to do like that. Okay, good. So I have my dry stuff. Okay. So we can see these are all, like I said, they are tailored products, and we can see that here in 1944, the risk tolerant farmer would have missed it because there were dry days within that period. But the risk averse farmer would have got 146, which is going to go beyond, I think, 18th April. It's about, again, over 37 days. That's like over a month period before he started growing. And so maybe likelihood that this person's seedling would have died if he went on. But if you went to 1945, the risk tolerant person kind of thinks because he didn't have to wait. The season really had started at that time, 129, the same, 34, and the likes. Okay. So basically, this is another form of tailored products that is just around the start. You can do an analysis as you check the 57. Yeah. Yeah, that means there was really a very long dry spell within that period. Okay. So yeah. So yeah, that's how this works. Again, we can use this to make graphs. Okay, I'll see if I can do one more thing. Again, if you go to climatic, you go to prepare, you can have the end of rains, and you can see there's length of season, spells. All of these are tailored products. So I'll do the end of rains quickly for that same one. Okay, so it's for this definition, it's saying that where the water balance goes less or equal to 0.5. Okay, the first day by which the water balance goes beyond 0.5, 1.5. And the water balance calculation has got something to do with the amount of rain coming in against those that is evaporated and what's will be in the soil as at state. Okay. We normally just, and again, this can change. Again, this comes to the bit of why it's a tailored product. So if your soil capacity, retention capacity is maybe lesser or more than this also comes into play, because when the rainfall, not all of them sips into the soil. Some runs off into other water bodies and things like that. Again, we have kind of made this a constant to say that every day 5 millimeters of rainfall or of water is kind of evaporated, but this could be variable. So when you have a data on evaporation or parameter on evaporation, you can use variable and then put that column. Okay, so you see it gives you a receipt and you can put that column and then that would go. And then where there are NAs, it says that you should replace it with 5 millimeters being evaporated. Okay, but for this work, we do not have evaporation data, so we just do this. Yeah, are you asking a question on this dialogue? Okay. The one before. Okay. Then let me just generate this and then we can. So this goes just with the end of season, okay? No. Let's see how. You see why we have a lot of NAs. Can someone tell me why? NAs. Why we have a lot of missing values? Because they don't have what? No, I'm using the current. There's no data. So who remembers the definition of the what they call it? The condition. Yeah. So basically, I think what the problem, let me just show this. What the problem is, I didn't really select the day range. Okay. I just thought it's starting from January, but normally, again, your climatology kind of works here. We would think that in the north by October, or they should start seeing the season ending, right? So let's do October. Yeah. Okay, good. Good, that's a good spot. Huh? Good. And that's why my okay wasn't coming. Sorry. Why you say something? No, you were saying why am I using the Tamalis by station year data? See, and that's right, because that doesn't have the whole data set. It's just the summary of the start of the range that we have. So it's good to use there.
You choose the second term, which is the end of season.
Yeah.
What's the difference between the end of range and end?
Again, it comes to what is they call tillage. Okay, so the end of range are for some people. And then I think in is it Zambia or Malawi, one of those areas, we use the end of range to calculate the end date for them, because they have a slightly different definition of how their season ends. Okay. But within this our area, the end of the season is good. So we can see that's been a bit feel better. But you wanted me to
the additions of I've been getting the number 15.
yeah, it counts from January, yeah. So that it helps you get there because this is Julian day. So it gives you the Julian day. It's not the April, no. So it's a Julian day number. From
Yes, this is given in Julian days, the date that the season started. So we're checking from day 1 to day 36.
yes. So you see, when you set the condition, it says from day 90 to day 366. So any day it's count, it picks as the start of the day, the day. It picks its Julian day number. Okay.
This starts with January, and the season year is April, which is but the actual data will come. It's comes with data.
Yeah. And what I wanted to find out was that
It's the same thing you guys are saying. You guys are saying. So when you were asking a question,
she was trying to understand the question.
Okay, good. If you understand, let's just go. So now, what I'm just saying is that you can make graphs with these as well, just like you were making graphs with the annual and the monthly and the annual monthly together. And to do that, as I showed you, there are other things, but because of time, I think we probably would have to look at those later. There's a length of season, which is just a general just subtraction and from the start and the end plus one. That works. There's a spells, longest dry spell, and there's the extreme. I'll try and show you the extreme instead of going through all of these. So to make the plots, again, you can just go here and then we want to do normally by station, okay? And the variable here can be, let's say, we want to do multiple. Let me just do all of them. Some of them are the same, so it's gonna be good. My X variable is the year. So it shouldn't be, that's not. Do we want any fixed options? Sorry? I do not want to put lines now. So because they are very small, so it may make that thing present to show. Good.
Yes. If you change the script here, that affects the input one or the one that you're working on.
The one that you are working on. If you want to go to the two scripts window, yeah, it just works on what you are working on.
So that affects the input one.
The inbuilt one, no. The inbuilt one remains the default. Anytime you want to change something for what you are doing, you just change it there and it runs, and then it's just what I want to get. So I put all these graphs together because I don't want to go over all the graphs, and just like I said, because of time. And we can see this is the end of the season graph. Okay. And this is the start. The normal start is the red line. The dry start, which is for the risk tolerant person, is the green one. Okay. Do we see? Yeah, it still gives you that. I just didn't want to use it here. You go to lines. When you go to the pixel. But you guys see this, like it's just the same kind of graph and gives you information. Okay, you can decide to just put one graph there. And another thing I like about this is you are able to kind of change the Julian day number to the dates. Okay, the date. So I can see, instead of seeing the 90, seeing 90 here, I'm seeing 1st April. Okay, and then I can go what that's okay. Are we good? To more grid lines, that's possible. We'll keep starting. Okay, yeah, it does allow. Okay, so if you want to do grid lines, let's see. Or in here, you can add the tessels if you want to. Not there. You've added them. Where? No, not this as I've just read. This starts from 1940 to 2020. Let me see. Yeah, I'll just this actually the first steps is not 20. The steps of 10. Let me see. 5. See. Yeah, that way. You want more, or you thought it was that one? I do understand, but I'm just saying. So if I've done just the Y, you wouldn't ask for X. So it's 1 month now. You probably can do 2 weeks. Yeah. Or 1 week. Yeah. Is this okay? Or you now want the diagonal one?
When Maureen tried, she got the answers for it. She got it.
Nigerian days. So when you, yeah, so when you go here, fixer options, and you are here, you have numeric and you have date. So go to date. Okay. Cool. Yes, I guess that's fine. Yeah. Okay. So I should put it back. Eh? Yeah, sure. Okay. Good. What's one thing we kind of notice about these graphs? One big thing, as meteorologists, now analyze these graphs as what do you think? What do you see about the end of the season graph? Again, even with the start of the season, I know it's a bit messy here. Do you want me to get rid of one of them so that we just pay attention to one? The start. The normal. Okay. So let's do this. Yes. So what we see about the onset and the end. Vicky, you want to say something? The way you are smiling and looking at me. You want to say something? So guys, what do we think? I see the other people online. So if they want to say something, they can unmute and say.
I see that there's
Okay.
The variability.
Hello, guys. Please let's pay attention. Someone is speaking.
The variability in the onset dates.
This discussion is important, so please, for the next session.
There's more variability in the onset dates.
There's more variability.
Yeah, the variability is very high.
Yeah, that's interesting observation.
I think if you also it cannot provide it yet. Because just at the goal, whether it's really increasing or decreasing or probably maintaining, you cannot tell.
So you want no trend line. Before you even put the trend line in, what can you say about it? This is a variability, the most pronouncing. So you wanted the graph just one on its own, or what were you saying?
So I was saying that from here, fine, you could make a judgment that whether it's having an increasing onset or decreasing onset or probably is.
What do you see from this? Can you not see?
No, from this, I can say it's decreasing, but
I'm missing data. Guys, let's yeah. There's no data, it's missing. Good. So you were saying
I'm saying that just generally when you see, I would go with the judgment that there is a delayed onset. So
there's a delay.
yes.
Yeah, generally the last 10 years.
Yeah, it's beginning to delay.
The last 10 years.
Yes, and okay, so based on that, are you saying generally for the whole thing, or you are saying for what? You are saying last 10 years.
I'm saying when you look at
that based on like if I'm making a judgment, all right. Just visually, I can say it is having a declining onset.
I mean, based on what? At least you should be able to point out some few.
Excuse me, someone is saying something.
To us, something from the graph, but to say generally, you think we are approaching a late onset or we are getting late onsets. I don't get what you are trying to say. So at least you should be able to tell us, maybe looking at maybe the last 10 years, the onsets are getting late due to this and that. You have to point out, but you don't say generally. I don't get what you're saying.
But when I say that, that's my view. All right.
It's not your view. We are looking. We are trying to read what we see and interpretation, but you don't give it.
Okay, good. That's good. A good one there, Bini. Thanks for putting it in.
So when you look at the onset too, I don't know. It looks like there is a certain cycle, even though it's not clearly defined. You check around 1990, is it 93, 92? You see that there was a very late onset.
1990.
Those are the 90s, and it's 50, sorry, 50, between 50, it's 1950 and 50 years. You see there is a late onset. Then after, I think, is it 10 or 20 years, there is a certain late onset. Then after some time, then there is a certain late onset. But after that spike, that late onset, then it tends to be more closely related to the, is it the normal? But when
what's the normal?
From this one, probably we can estimate the normal to be between, yeah, April, the 25th and May. This is just a rough estimate. This is not the calculation.
So generally, if as a meteorologist, if you want to tell someone something about someone, the onset or the end of the season, what can you tell the person as a meteorologist? Just give the person an idea. Maybe the person wants to take a decision based on what's been happening in your area. What would you say to the person?
For me, if I'm looking at advice, if I'm looking at the last year, that's where I think that
Is it okay for you to give an advice to the farmer based on the last 10 years? When do we say a trend? You know, the trend is in a sense also trying to say that there is a change. Yeah. If we say there's a trend, it means that something is changing. Are you going to be telling the farmer that because of the past 10 years, there is a change in the way the season starts?
That is why I said this is going to be only for the super.
So let's everything else, every other condition that I say aside, we are dealing with this as a standard now.
You know,
Is it enough?
It's reasonable. For me, you can look at it, when you look at all the years, there are some years that you see that the season starts in June, but fewer number of years. Mostly it is within May and sometimes within the second or third week, from the second or third week of April. So generally, when you ask me, our position is that you can look mostly around May.
But would you be telling the farmer that it is changing? Because that's what you're saying. You're saying that for the past 10 years, there is a trend. Is it a positive trend or a negative trend? It's a negative trend. Negative in terms of what?
You are now getting late onsets. So it's negative.
So it's positive. On the past, it's positive.
No, on the graph, yes, it's positive, but in terms of
Yeah, that's what I mean. Let's speak with the graph. So you are saying that there's a positive change.
yes.
So you probably be telling the farmer that there is climate change.
No.
But what does it mean? The trend means there's a change.
That is why we also say there is high variability.
So
we're not testing.
sorry, yeah.
But we're not using this.
Can we hear, guys? Let's hear Bobo. That's what I'm asking. Uh-huh.
So that is the reason why
That's what I'm.
generate the trend directly. But from here, you cannot generate the trend.
No, but I'm saying you see it, guys. If you see it,
I didn't hear you. Sebobu.
hello.
Before 2010.
Let's.
I can't hear Sebobu.
You can't hear Sebo where he's saying there's no trend. That's what he's saying. It's a bit far from there. Next time when you are speaking, there are people online. So if you can put on your.
I'm saying from the graph, they always say annual.
That's right.
I'm cutting the
Fine. Yes. Good. Good. So there's no clear cut trend. Yeah. That's basically what we are all. I just wanted to know, because if there's a trend, we probably will be seeing this going up there or it's coming down this way. You get it. But what is more visualized or seen from this is the variability. And we realize that most farmers now, when you speak with people, they go like, oh, the rainfalls, this one are decreasing. Then when before we could plant very early, even in March. But you come and look at your data, and your data is not saying that.
My boss said, it's my boss. But that's why I choose to hear it. And I'm saying from looking at it, and that's trends. 2010. Look at 2010 coming. It's only around, I don't know if it's 20, just one. Only one is great for out of all these points, I see there's a rise.
Yeah, but I think his point is that you don't just look at one section of the data set and say that because of that there's a trend. You need to look at the thing in whole. And again, as meteorologist or something like that, you normally know that the climatology, what you talk about climatology is supposed to be at least 30 years. You can't tell somebody something about a certain place by using their past 10 years. You need to look at at least one climatological period to really be able to say something about the place.
Yeah, but I also feel it won't be out of place. If I notice something that is happening, to draw attention to it as a way of drawing attention to it. The last 10 years I've been observing this trend. I will not have to conclude that probably we are going to get more late rates. But out of 10 years, you see, look at the dates predating the last 10 years.
Okay.
Even though there are variability, but you find out that most of the years are within, I think, the last week of April and the first week of May. But for the last 10 years.
Okay, so if Nana was a meteorologist somewhere here, he probably would have told a farmer here that from what I'm seeing, a farmer at this point, you'd have told a farmer that from what you are seeing, there's an upward trend. Well, the past 10 years.
It is not clear. Here,
why is it not clear? There's a trend here.
There's a cycle.
That's the first tonight.
To me.
Yes.
Hello.
Okay. Wait, I'll take him and I'll come to you. Yeah.
Yeah, to me, to get a trend, you have to draw the line of best fit.
Yes.
If you try to draw the line of best fit, you see that for the starting, there's a
You see?
trend. But for the ending season, there's a decreasing or almost constant trend.
It's if you draw a line of best fit for this line,
Yes.
you will not get yes, I know. But what I'm saying, the gradient is going to be very, very something very small, either in the positive direction or in the negative direction. And I get it, but what I'm saying is, for you to have a significant gradient or something to talk about, you just don't look at something that's something is going to be like not, but it's not something, which is almost like a zero thing. If there is a trend on something, you should probably be able to see that there's some. When we look at temperature, we do the same thing for temperature. You personally see that this thing is moving upwards. Okay, but you can't say the same thing for rainfall. What is more emphasized in this graph is the variability of all as you all have alluded to. Yes, sorry. Sorry, I wanted to take
What I'm saying is, if you look at from the graph, what Nana is saying, I think you agree that even though there is no trend, the one can use this the farm. Because if you look at it now, from the last 10 years, and this.
What advice would you give a farmer from this?
The onset is not decline. There is always a push for a delay.
I get it, Patty. What would you advise a farmer?
If I were to advise the farmer, based on these 10 minutes, I will tell the farmer that this variability is expected to continue. So therefore, you have
variability or change.
The change has to continue. Either of them. And advise the farmer to go in for a stop. That is a long short
variable.
So that you're able to cope with this.
Yeah, but that's my point. I'm saying if you were a meteorologist here, okay, what advice would you have given a farmer? Because this last 10 years you are talking about, remember that in this period, the season also dropped here. Okay, in this period, they were just almost the same, and it's gone up. What is the probability that this is going to go up? Because you are telling the farmer that he should go and get a shorter crop variety. What's the probability? There's also another probability that this could drop. If you are looking at what has happened here.
But the probability there for it to drop.
How are you saying that? Yes. Amsale has I think Amsale has a contribution. Let's
yeah, I mean, it looks like people are more interested on the trend. So maybe if you put the mean, if you put the mean line, yeah.
But the mean, well, I could do that. I think the most things to emphasize in this whole thing is a variability thing. I could put a mean line, fine, yeah.
That's right, but they keep on mentioning on like the trend.
Let me just try and put in the mean line. I don't think it makes one, but
I think it is actually once I'm advising, it's only together that I draw that once. I cannot do it on the basis of that. Just upward. But at least notice it. Understand that there is something usually happening. If it calls for further investigation, maybe let's have a look at it. Based on this, I might tell you that it's going to be
yeah, unfortunately, you can't fit the line. you come back here. Good. Yeah, I'm sorry, I just fixed that. Is that something new?
All right. I think it's coming.
Yeah, guys. So, Patty, you were concluding.
Yeah, what I was saying is that if you look at the reason why I'm saying is because if you look at the
Yeah.
1990s,
Guys, let's listen to him so that it is.
population that we had in the 40s, the 50s, up to the late 90s, comparing to now, and the way we were living before, and the forest cover that we had before. And now you see on the forest and the type of industrial licensing that we do now. Also the fact that is possible.
Yeah, but the thing we are saying is that these things we are saying are real, like the vegetation is reducing and things, but there is not enough evidence with the eye. As when you look at something like temperature, you can clearly see that this is increasing. It's not the same with these variables. Rainfall, you are not able to see that clearly without even putting a trend line. Good, yeah, sure. Yes. Sorry? Yes, yes. Whether there's what? And we can even fit a trend line. Yeah, we can fit a trend line, but I'm just saying, you know, there are things which you do theoretically and practically, they really do not be able to give you that much things in practice. If we look at a trend line, I'm very sure you never get something like 5 or 1 day, maybe 0.2 or 0.02 or 0.0 something. What does that mean in terms of days? It means that it's taking maybe, if it is 0.03, means like an hour of the day or something is being added to this. And how is that really significant? And it will tell you that it's significant, probably, yeah. But how is that not that 1 hour significant? Because you are not looking at hour in terms of this. Because if it is not one, if it is not a whole number, it is not saying anything about days, that it is increasing by this number of days. I don't know whether you get my point. So not something this one. How is that really significant? But with temperature, if it is 0.02 or something, it's an increase in the degrees. I don't know whether you get my point. And even a 0.1 degree increase is really valid. So with the rainfall or with the start of the rains and end of the rains and things like that, if you are to see like clear trends, and I'm saying that we should not just pay attention to what do you call it, to just parts of the graph. Okay, we should look at this as a whole, because this is something coming from that same place. Okay, if I come and look at just this side of the graph, okay, and based on this side of the graph, I tell or I'll give someone an advice about the place. Am I being very, very true to the person? No, you get it. And climatologically, the WMO tells you that if I really want to do that, I should really be starting somewhere 30 years. Like here. Yes. If I'm starting from here, would I be able to tell someone that's kind of thing that the thing is changing? Do you understand it?
But you could see when you started from the 1980s, if you divide it into two, you could see there's a cycle.
For every time series has these three components. Okay, the cycle, the cycle, the seasonality, and the trend. So for most time series, you should find these things with them. If one is not having something on seasonality, it probably has something on cycle. And so I won't dispute the cycles and trend. But the thing is, I'm saying even this, you probably would find a trend. But the trend, is it a trend? If you do it mathematically or theoretically, it will tell you it is significant. But in practice, what is 0.02 of a day? And how is this really? How do I say? How is this signal? How is this in practice good to a farmer? Like, what does not something?
For the onset, all right, there is always a range. It's not a fixed thing. So if there is a slight deviation, it might not be so significant unless it's so extreme. You understand?
Let's see. 1969. 1969. 1972 where it went. Okay. Is that a slight?
No, this is the major.
So what I'm just saying is we need to consider all of these things together.
Yeah.
Okay. And say that there is variability. What you can probably give, and that is what picks at us, which I'll come to in the next presentation, is to give the farmers or something what are the chances, because maybe you say, okay, the farmer wants to know that he wants to plant maybe by 23rd May. Okay, what are the chances that if he started by 23rd May, he's going to be able to grow his crop? Okay, just by having this, counting the number of times over the whole set of years, gives him an idea. Say maybe if you really want to plant by the 23rd May, you have this chance or something of being successful. If he reduces it, his chances kind of increases. Do you get my point? That is a better way of, like, expressing or giving information to farmers than. So I'm just saying, if a farmer wanted to plant by 11th April, okay, and he wanted to know his chances of being able to plant by 11th April, okay, by 11th April this year, if he puts this kind of 11th April, we can count the number of times. He wanted to plant before 11th April, so by 11th April means before 11th April. If you count the number of times by this 11th April, which are the points below and on that dashed line down there, it would tell him that, oh, well, if you planted before 11th April, you have maybe 10 out of how many years of data? We can do it. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Out of 1940 to 2015, mathematicians. Done. And so it's like 22 out of that's about 40 out of 80 something, okay? Out of 80 something, and that's about one out of 4. Okay? If he increases to say that maybe I wanted to grow by 9th May, remember that his chances kind of increases, okay? So this will move from 1 out of 4 to about 3 out of 4. Okay? Or even a 50-50 chance. If he increases it and say, okay, I'm not really comfortable, let me do 2010. He's almost getting in this whole period that if he plants by 2010 May, he can, or he'll be in the season. Do you understand? I don't know whether you get my point. So once we emphasize that variability is a problem we see in these graphs, then that's the way to go. Sorry, you wanted to say something.
Still trying to because if you are done like that, because you have had rains falling for ignoring the fact that some few years in the past, I mean, for the last 10 years, has taken a particular, let me use the word trend. And you are ignoring that and facing forecast of that fact. The fact that more years in the past have fallen our states have gone forward. Therefore, I think that's a fact. Doesn't really sense.
Why not?
Yes, still because of the last 10 years.
And I'm saying that as a meteorologist. Okay.
You are using the data. From what you are saying, you are talking about experience. Using experience. No. Because the data is the graph. The graph has given us the
Guys,
let's 30 years. This is what the graph is telling us. So unless you want to tell me that your experience in the last 5 years says this, it means you don't have to use the graph anymore. I don't know what I mean.
The graph.
The graph has given the mean. So the mean means the probable.
Francis, there was a part, we were on the phone from January, please. In I think number or something. And for us, we are not trying to establish that the last 10 years or so means there is a change. The participants asked us, the last few years, we have been noticing something. What is it? Because they've been noticing that within the last few years, they were seeing that their rates were not starting on time. What is it? So we have to tell them, we cannot attribute this to climate change because we have not done any extensive work on it to determine that indeed it is a change. But however, what you are seeing or you're observing is also important. Let's keep on looking at it. Let's bring in other factors to see whether even the built-up environment is changing. Let's look at it, take notice of it, because it's something you are saying that you have been observing it. But we are not trying to establish the fact that there is a change.
My question to you again.
They were telling for the last 5 years.
Okay. Guys.
What I said, they are concerned.
Guys,
remember, your product delivery is for them.
Guys, let's be attentive. So let's use this class. Let's pay attention. We now pay attention. Okay, so here, guess the last 5 years. Okay, 1, 2, 3, 4, 5. Right? And I think from this past 5 years, the data is increasing. Is that what you want to tell me?
That's what the farmer is asking.
Yes, but that's why this guy, I like the question that Sammy asked. For how long are they are they the people who keep data, or you are those who keep data?
And you see, for the farmer, they don't care about that.
Yeah, but that's what I'm saying.
You see, they always want to relate to the last bad experience or good experience they had.
Yes, but that's where I'm coming to. If you ask people about bad and very good experiences, they only remember things which were really good to them and things which were really bad to them. They will not remember the normal things. They will not really remember the normal things very well. So there's always good to use. If everybody talks about 83, everybody knows that 83 there was hunger. So everybody can easily go back. Can you tell me about 2015? If they talk about the day there was floods and carrying things, we can remember those days. But those normal periods, we will not remember. So maybe in the past 5 years, somebody has seen that, they did your home day and buy or 88. Of late, your home day and buy. Okay, sorry. So what I meant to say, In 83, sorry, Sanjo, so 83 is one of our very worst years in Ghana in terms of like harvesting. I don't know about the data, the rainfall data, but in terms of like I wasn't born then, so I really. So, but what we are trying to say is that the farmer in maybe 88. Sanjo, I hope I'm speaking English now because I'm speaking to you. would remember that in 83 of late we've been having very bad seasons just because of an 83 bad experience. Okay, if you talk about 87, what happened in 87, what happened in 86, what happened in 85? We can't really tell you whether it was a bad or good experience. But they remember that very bad one. In years when they had very bountiful harvest, this year there were a lot of food. They remember those years. But the years where it was just okay, they really won't remember those things. So all I'm just saying is, if you are using what the farmer is telling you that, in my experience, the season has been going farther away. Is that what your data is saying? For their place, because they don't record information. They only judge by what they remember. You understand? And so, how do you help them believe in what you are giving them? The only way you can do that is to show them evidence. You ask them which year was the bad year. They say, "Oh, this year." You go to the data. If really it was a bad year, you should see the data dropping in terms of rainfall, because the data doesn't lie. You get my point? So I'm saying if you want to give the farmer information, and I'm just going to look at this, even these 3 years, there was a year where they were almost the same, on the same level. You get it? And there's only 1 year where it's gone up. Within this 5 years, which we are saying, this year it's dropped. This year was a normal year. This other year is just one. There's just only 2 years where you can see that it's actually increasing it to 10 years to start from here. It's gone up and down.
Brothers, how do you mean that it's 2 years and 1 year?
Normal as in they stay the same.
But they are still above there actually.
Yeah, but no, find me the mean of these 5 years. We don't use this mean to determine. The mean is what so
you want to use a new mean for them.
For them, you can talk about that 10 years as a different. But that's what as a meteorologist or as a climatologist, could you base what you tell people by 5 years? Hey, no.
I mean, you can't imagine. That's why we have a lot of information.
Automatic.
They should be telling us that for the 5 years they are seeing some experience. Should be underestimated what you have the climatology behind their mind. I mean, they seem consistently that kind of.
I've not said that.
No, that's what
I've not said. What I'm saying is that what is the change that they are referring? Can they quantify it? You can quantify it. And so whether that change is significant or not is the data that will tell you. But you cannot use the farmer to say, of late, the season has been starting late. How late? What does it mean by late?
see, if you take this from normal, that we should the focus to the first message. If they are speaking or something and
that's what we are saying, that they do not need to rely on only one past year to make an investment.
we agree, but I want the whole data setting is more than 30 years.
Yes.
Saying a lot to us. Maybe let's say picking that name out, that don't give the response that they become plus or minus. So picking those plus or minus, let's put it around even April 11 to around
Forgive me, but this is historical data we are dealing with. I don't know whether your forecast, I think there are a lot of things that's kind of happen maybe right now and things to make a forecast. Okay, so this is just historical data. It's based on historical data, and maybe when I start showing you the fixer slide, you probably would understand a bit how different this is to the kind of forecast you do. But this is something which has happened in your past. Okay, and WMO says that you have to use at least 30 years to say, well, I'm just saying this. I don't think you need to base your or advise someone per the past 2 years experiences.
So, even as we are recording our life, the things that happen through that, they have some similarities. That's what the normal people do every 10 years.
So I get you. So you are saying that.
We are looking at it in general. Then we don't like this stage, the nearest things that are happening now, as we are now saying, look at other things. To add to that based on Jesus.
I'm not saying this should change what you do, but I'm saying those other things you are talking about. Let's forget about those other things. You have done this bad test.
This is only thing that is still the methodology speaking there. And we think how we know the 30 years to speak to that. Let's also know that it's the farmer we're speaking to really at that location that the farmer. That was another thing. It's still that's the consideration.
So maybe you understand my problem. Whoever we are talking about has given us this data. So we are talking about a farmer at this point. Who has it? So everything should be centered on this thing. There's an argument to put to say the farmer is not at the location. That one is another matter of it. But we are talking about the farmer at this location. He's given us this data. He's plotted this graph. So speak with that in mind.
And in reality, the data that happen like is what that their conditions that led to this thing.
No point. Indeed, what I'm saying is the farmer is standing here. The farmer is standing here. And this data we have there is from this point. Okay, so everything should be centered that it is really from this point. That is what we are talking about.
Every year, there are things that influence. That's what sometimes goes out, sometimes in front. That's what you're measuring those variabilities. So, in as much as we are even speaking to let's say the data, in reality, by no means the conditions.
That's what I'm saying. This is historical data. That's forecasting, right? It's got something to do with the elements in physics, in meteorology, and things. So when you are getting nearer to the time, there are things, but this is when that period hasn't come. Where because your forecast is mainly based with close to a set, you can only forecast for the next 3 months, right? Or is that correct me if I'm wrong? Right? Like if I'm here and I want to know, you can give me a forecast for the next 3 months. What is that? What I mean is something very close. But this kind of analysis is something which has been there for a very long while. Okay, so even when you are not ready to give the forecast, this is something which is a base which is there. Okay, and then as a forecast can we ever say throw away your forecasting? That's not what I'm saying at all. I'm just saying let's all come into the world of historical data analysis. This is data which has occurred again. Your physics and your things don't work again in this area. Do you understand? No, that is what we're talking about.
You ask if we are advancing. You ask if we are advancing.
Yes, at that time when your physics and thing is not ready yet for your forecasting.
You see the 83 example. 83, I think was an early year, starting from 82. We had 83.
And I'm not surprised that
so exactly. So if the previous years or the last 30 years before 83 we're having sort of rains here and there, and based on that statistics and advice found, and because of that, we're going to have rains in 83 without rains.
What's going to fail? Sorry.
Forget about that.
That's what.
I'm saying, just looking at the historical data, I'm saying because you have had more years of rates, and therefore I'm giving you a contract. And I'm telling you that just before the election, the last 5 years before there was a particular trend of trying.
The long and short of this whole matter is, do we see climate change or climate variability in our area? We want to advise based on, because when you say there's a change, you are saying people should be expecting that the change continues. If there's a variability, you are saying that, well, this is very variable, we can't really tell. But there's a probability associated with any of these things. You understand? When you say a change, you are saying that expect that the temperature keeps moving upward. You understand? Yeah, so my thing here is it a variability case we are seeing witnessing from this, or there is a change which is either going up or coming down? Basically, so basically that ends the conversation. Okay. Unlike temperature, which you probably will be saying that expect the temperatures to be increasing. You understand? So that is just the argument, the whole thing here. It's more variability than to say at the end of the day, sorry, the thing keeps increasing, yeah, or decreasing. Are we good? Okay. Let's go on. Yeah. I wanted it to be a bit more, you know. Okay, good. So let me just show you one more tailored product, and then we move on to beta. So let's do the extremes. Okay, so as you saw with the summary, guys, I'm moving on. Maybe let me revert back to 0.5. So I'm back on 0.5, 0.7. Guys,
Why? The 0.5.
you go for the prayers again. You see the driver. No. I just want to go so that everybody can practice. Guys, so we are continuing. What can say? How can they correct it? Why?
No, I was inquiring about this climate change, climate variability thing. Do we have a data indicating that this is truly climate change?
Yes.
It's a variable in the climate.
Yes.
So it's a variability. When you say climate change, you are talking about the entire, you are not talking about a variable in it.
Okay.
Yes. No, you don't get to. Yes.
Yeah, so
obviously you are trying to say that there's no climate change.
No.
Definitely a variable will change. So
you expect all the elements.
No, but you see, again, hello, I think, guys, we want to move forward. But I think Kwame has a point. You see, when we say that the elements of the elements of climate speak to each other. If temperature is increasing, you are expecting that rainfall, the evaporation and things like that would be a bit more, you understand, and it would affect others. So he's right to say that, well, if this element is changing, we should be expecting a certain change in the other elements. But as it stands now, especially for this our region, we kind of see that the temperature changes. However, that change in rainfall is not very, very obvious. Like you can't really see that change yet. Maybe at some point in time it could be, and the change can be in different forms. It can be like maybe like say the season start has now moved away. Maybe the amount of rainfall has now kind of increased. We are now having fewer days of rains and more rainfall, or we're having less rains, and so it can be in so many facets. You understand? So I think he has a point when he talk about climate change not just being temperature change, but all the parameters of yes.
Yeah,
but what you say? Okay, guys, climate change is for another day. Let's make some progress. All right. So let's go on. So extremes. Let's look at extremes. We go to climatic now. Please do as I do. Prepare. You go to extremes. Remember that when we did the climatic summary, we're able to choose maximum and minimum. Okay, and that's only give us like the amounts. But this dialogue gives you something more than just amounts. Okay, so we go to the mean, max, that's there already. You want to choose the elements. I want to look at rainfall, so I choose rainfall. Okay, and then we want to look at the maximum values. Say it should include the first date and then include the number of occurrences if there were more. Okay, so the whole year. Okay, and then you do okay. Good. Do you see how different this one is from the earlier one that you had done in the climatic summary? Sorry? So the difference here is the fact that it gives you the maximum amount, okay, of that year, and it tells you when that maximum amount was found. So in 1944, 18th April, we found the highest amount of rainfall to be 64.3 millimeters, okay, in Tamale. In 1945, we have 57.2, and that occurred in 6th July, okay, and so on and so forth. So now it kind of gives you when that thing occurred, and further analysis and things could be done on these extremes.
So how different is this one from the annual daily maximum?
This annual daily maximum. Yes, but now when you do it in the climatic summary, you don't get the associated date, because there was some people, somebody was asking me, is there a way you can find the date that thing occurred, that highest amount occurred? Okay, and this is how you find it. And then there are some years, very rare, because you know, the way rainfall is measured. There are some years where you would have the that occurrence occurring maybe twice or thrice within a year, and not just once. And so the N max gives you the number of times that max would have occurred in a year. Okay, right? Cool. Is it what? It would write two, yes, and it will give you the other dates as well.
But let's see what is happening 2 days. Let's see whether I give it 2 days.
Which two? Where do you see?
Put it down. I saw two somewhere. See two.
Yeah.
I'm giving out 1 day.
I'm coming.
1982.
Just a minute. 80.4. That was in 1982. Okay, I think the idea was to do that, unless I really didn't miss.
Maybe the first.
There's supposed to be something. No, I don't think this is duplicate. It should have shown the other year. Yeah, so maybe it's just because we don't see any other two again here, right? So there's just there's only 1, 2, yeah, 1982. So it's either maybe it's just given. It's supposed to give you the other one as well. So, or maybe it's saying that there are 2 times when this amount of rain, and you said the first max date, so it gives you just the first max, but it's telling you that the date, the amount has occurred twice within the year. By giving you the first time it's occurred. Let's see if there's a facility to see more. Include last date of occurrence. Okay. I don't see it.
The first date and the last date.
Yeah, okay, yeah.
Different dates.
There are different dates, yeah.
Those with one, they're the same date.
Yeah, so in May also you got it. Yeah. So you need to check that box before you can get that other information. Okay. But the occurrence will be seen in the NMAX. Yeah, they are there. So the first one is April 6th April, and 1982, and the second one is 18th May, which is on the right side. Okay. It delayed. Okay. Good. So that's it. And you can further go on to do further analysis, maybe like looking at the distributions of the extremes and things like that, or modeling the extremes and things like that, which is one of AIMS students is looking into making it like a system in R-Instat. So for now, you can just have access to these information, and then for the modeling bits of it, hopefully the newer versions would have that component. Good. I think I'll stop here. No, am I stopping? I shouldn't stop. Yeah, so that's another example of tailored products that people will probably
want to check what the transpiration.
We don't.
I wish to confirm
what about it?
So we normally verify whether the transpiration. So if they have this,
yeah. Yeah.
We have
Nina. Yeah, so okay, let's do this before you go for break. Guys, Wami, wise. Let you phone. And maybe Apple used to do that.
Yeah.
Okay, guys, so I now want to tell you about Pixar, okay, which is one approach that is related to providing tailored products for farmer decision making. Pixar, as its name stands, is a participatory integrated climate services for agriculture. And it's actually an approach that, like I said, that comes in trying to prepare information for farmer use to enable them their decision making, their daily decision making. Raj, you know it's working. Okay, so basically for this presentation, I'm going to explain the Pixar approach, how and where it was developed, where has it been introduced, outline the overall aim with work with farmers, explain the Pixar timeline, which is mainly the well before the season, just before the season, during and after the season. Explain a step-by-step approach and how it progresses along the timeline. Okay. So we know the challenge, or what actually brought up Pixar has been with the usual challenge, which has been that smallholder farmers are really key to the food security, okay, across most places, especially the developing world areas. They need to make critical farming decisions depending on the climate, amongst other things as well. But climate has been one of the major things that they need to make decisions on. So they are interested in things like how much rain is falling, like am I getting enough rain for my crop? Are there extremes in temperature going to affect the way my crops are growing? If there's an extreme, how much extreme and how is it going to affect the crop I'm going or deciding to grow? They want to know whether their seasons are getting longer or shorter. They want to know whether the start dates are getting later or earlier. These are things that some of the farmers will want to know when you speak to them. And like we have seen from the Tamale data, these things vary considerably from year to year. Okay, it is never very clear as to whether they are moving in one direction or the other. So the whole Pixar kind of started in Zimbabwe as a pilot project, I think in 2011. It's been led by a group in the University of Reading, Professor Peter Dowd, Dr. Graham Clarkson, Professor Roger Stern is part of the team, and there's some post-kits. Okay, but actually this started in Zimbabwe, and they had a pilot on it in around 2011. In about 2013, the Tanzanian Met service made available their data, which you probably, if you use R-Instat a lot, will be seeing that data set called Dodoma. They made available that data set, and so it was a good place to really start making or trying some of the Pixar's work. So through some form of funding system, they started to do it in Tanzania. And then, as you can see now, Pixar is almost everywhere in Africa, especially Eastern Africa and most parts of Western Africa. And it's also been in places like this South America area, where we have the Haiti, Guatemala, Honduras, Nicaragua, Colombia, and Guyana. Okay, and then it's now also moved into Asia. Bangladesh is currently using Pixar and things like that. One thing that they realized in these places is that what products ever they kind of produce for places like in Ghana, especially for the climate information, they are not the same. They are not the same kind of products other countries kind of want. I got the opportunity to be in Lesotho, which is Southern Africa. And at that time, I had the experience with working with the north of Ghana. By Lesotho, when we got there, rainfall was not too much of the problem, okay, in terms of knowing how what is the 20 millimeters and start of the season and things like, because in Lesotho you have snow sometimes in the northern highlands, high area. You know, Lesotho is already a highland, and the place normally gets cold. Sometimes get frost on their crops or on the land for a while, and so before it even gets into the rainy season, the frost could be there, and like it could be melting into the soils bit by bit, and maybe too much frost and thing was also a problem. So they kind of want to find things about when was the first frost, when is the last frost, which we don't do here, that kind of thing. But it helps with their decision making, which is all part of the ensemble of things. All right, cool. Sure. Okay. Sure. So, like Pixar, it has farmers in the middle. Okay, it has farmers like in the middle here. And like farmers have challenges, which include things like markets, value, and the rest. Climate is one of the important challenges that farmers face, and Pixar tries to address that using historical records. And can you please close the door? Historical records, which we have shown some of it with you today, and then the seasonal forecast, which is both seasonal and short-term forecast. So these are the information that Pixar uses. It also tends to look into things like options, okay, where they kind of provide through the challenge that these farmers get. Okay, they try to provide crops and livestock with livelihood options that could help these farmers address some of these challenges they face. Okay, and then in providing these options to them, they kind of use participatory decision making, which is the last part of the whole Pixar process, in helping the farmers make these decisions. They participate in making these decisions. There are two main principles that kind of govern the Pixar process, and that is one that the farmer entirely decides. The farmer is the one who says, "I want to do this." You don't go and say, like, unlike other general interventions and approaches, which goes like, "This is the best. You should all do the best seed." And the reason why Pixar enforces that it should be the farmer that decides, because we have different options per your context. So per my context, I could probably be a very old farmer. And so therefore, what a young farmer would do, I cannot do. So you cannot give me a bracket kind of method or decision to take. So I'm doing what the young farmer is doing, you're expecting me to do. By all means, the young farmer will probably make more gains than me because he has lots of energy. There could be sick farmers who have leg cards. There could be females, what males can do. They always say they can do better, but there are still things which a female farmer would do, a male farmer would do differently and all of that. So we per your context, you are able to say that, well, I would rather do this or do that. A rich farmer may be able to kind of invest or take a risk that a poor farmer would not be able to take, because when the poor farmer invests all his money into that venture and it doesn't go well, he or she will probably be in trouble. Okay. Good. So that's the reason why we emphasize that the farmer should be the decision maker. Okay. So these are some pictures of farmers working on the Pixar. Okay. So well, it may be a Muslim community that was visited, but on the left side, you see one of the farmers kind of drawing out what we call the resource allocation map, trying to find out what the allocations are, things like that. And then on the top right corner is Pixar is now trying to move from being on paper or to try and go a bit together, So this was one of the times where they were trying to pilot some of the activities with farmers there to see how well they could probably generate their climate information, or maybe generate their resource application and things like that. Yeah, you can see how they are smiling and paying close attention to that. The down part is one of the groups that when we went, we realized that in some of these farming communities, when a woman and a man are all together in a place, it's difficult for the woman to make comments or to bring out their mind or something on some issues. So what Pixar tried to do in one of their trainings or education to farmers is they try to put all the female farmers together so that they can be able to share their experiences or share their advice. We say that the farmers are usually the experts because they do the day-to-day activity of the whole thing. We just go there to support some of their activities. So yeah, we try to separate the females so that they could have the chance to express themselves better. Good, so I'll talk to you about the step-by-step approach of Pixar. Pixar is actually made up of 12 logical steps, 12 logical and clear steps. Okay, and the steps enable intermediaries. So the Pixar or developers of Pixar do not go and work with farmers directly. They instead get what they call it, extension officers, because extension officers work on duty is always to work with farmers. So if you're able to kind of put out the information or whatever we thought would be useful for farmers to make decisions, we then kind of pass it down to intermediaries, which could be volunteers or community volunteers or extension officers. And they who have been working with farmers know how to put across information that we want to share with farmers. We however note that sometimes extension officers are trained to be teachers rather than facilitators. And so we kind of stress to them or make it clear to them that it shouldn't be like they want to enforce things on people. It's to make sure that these are the various options that they are available to them, to the farmers, and then support the farmers to make the decisions by themselves. Okay. Each step, as I said, have a set of activities that these intermediaries, which are the extension officers or the community volunteers, do with a group of farmers in a series of meetings. So it could be 2-3 times, and then they would have done the whole Pixar process with them. Okay. There are 4 main steps or 4 main time steps of the entire Pixar timeline. The first chunk you see here is what we call the long before the season time step. Okay, and within the long before the season time step, there are about 7 different steps that the intermediaries work with the farmers to work on. I'll give detail of these steps in the next slide. The first step, which is the step A, is to do an activity called the resource allocation map or seasonal calendar. And then B is the climate change, the historical climate information, farmers' perceptions, and historical records. Is where we kind of work with what they are thinking is about the climate and what the data is saying about their climate. And then we have the C, where is the risks, which gives you the risks as to using, you help do the graph to kind of see whether get some probabilities of doing several things that you want to do, whether growing a crop or wearing a certain animal. And then what are the options available with the farmer? We show crop options, livestock options, livelihood options. And then there's a step E, which is the farmers choose the options to consider per their context. And then there's a step F, which is the participatory budget, just a bit detail on as to what is going into their farming and what they are getting out of their farming. And then finally, step G is when the farmer selects which of the rams and snap calendar they need to amend and what crops they are going to do. And then we come to the next big time step, which is the just before the season bit. And this is the seasonal forecast. This is where they kind of add with the seasonal forecast. So long before the season, the farmer will probably be there and just waiting for seasonal forecast information before he probably will do something. That's if it's a farmer who is reliant on what Met service will probably give him. So we thought that picks are things that all within that week, this whole set of activities will be good to do. So that gives them some idea about their situation of the place they are before the seasonal forecast comes in. And again, it helps them to identify and select possible response to forecast. Here, they could again revisit their resource allocation maps and amend them per the forecast that would have come to them. Okay. And then there's a short-term forecast which goes on within the season. Okay. So within the season, if they are having information on maybe, well, there's a big storm coming. So therefore, if the farmer maybe had decided the day before or that day to go and apply fertilizer or maybe pesticides, if there's a storm coming, it's certainly going to wash away all that they would have applied. So that gives them some ideas, and then they may delay it and those kind of things. And then there is again, so they revisit and make changes on their plans. And then there's the last one, which is the after the season. So after the season, they probably would review what they have done in the previous season, learn from their experiences, and then note what they will change in the coming season. Okay. So good. So I'll just go into detail a bit. As you can see, as I explained on the previous slide, the info there, the info that we kind of give these farmers on the whole picture approach is very, very holistic approach with lots of details. So it's not just something that you should pay attention to that fact. Okay, good. So the step A, which we said is the resource allocation map and the seasonal calendar information, is actually the farmer. We kind of engage the farmer to know what their current situation is. Normally when you meet farmers and you go like, what do you have? Because they know you are coming to give them something. So they go like, they do not have anything. But this is a place where you kind of throw light into some things they probably wouldn't have thought are useful, that could be useful for them. So we try to understand the farmer's situation. How many children do they have? How many houses or whatever they have? What again do they have? How many different kind of farms they have? The maize farm, there's a tomato farm, there's a cabbage farm, there's a sorghum farm. How many chickens do they have? They write it there. How many goats and things like this. I think this is pigs and these are the chickens. How many wives they have, how many children they have, well, whether for this farmer, he said he had a fish pond, or there's a river place where he goes to fish. He sometimes take the droppings of their pig onto their farm some way, somehow. What again? What is that? Which one? Well, they have put in some way, but they give some. You can see this is in, I think, Amharic or something. Arabic. So this may have been one of the I don't know, Haiti or something. Yeah. So basically, this just to basically know the situation of the farmer, okay, and then how the different things that they have to link up, okay. Sometimes you say that they probably would have a daughter who's maybe sewing outside the house or something, and maybe some of the proceeds that come from the sewing kind of comes to support the farm, the house or things like that. I think we just want to understand their situation, and then that helps us know whether this is a rich farmer or there are situations which you probably can fish out from that.
Okay. You see the sketch. Yeah. Okay. This one is more of like to explain to the farmers in that totality. Right. So now we can have the roadmap, right? So we can give a clear description of how their area is like. So if you are now putting something to what you will be able to understand better because it's a real picture. It's like more like a top definition of what.
Yeah. So basically, what happens is that because we use this not just to see where they stay. It's not just to see where they stay, but it's to see things which are available to them. There are some of the things you probably like a fish. If the fish pond, you are seeing it in.
I think these ones are also based on households.
Yeah, there's a household. Yeah,
Every household
has its own situation.
that household.
So this fish pond may occur in another household. You understand? So it's not just where their physical location, but to know things which, so like the daughter maybe who is the same stress, you probably won't capture that with Google Map, but they will tell you that, oh, my daughter does this, and so probably you put it somewhere, and then when he or she, and these are for the farmers, so when he or she sees this, he's able to know, okay, I have a stream of income coming from this place. I have this, I have 3 cows or 2 cows, 3 goats. I can sell one of them for this. I can do that. Like I have this number of fields I'm hoping to work on and things like this. It's individual per household. So every farmer does this for their own plan. Okay, and then we have the historical climate information. Here is where we show the farmer's graph. You know, and this has been, I'm sure maybe if I don't say this now, you probably say it as we go on. Can the farmers understand this? It's a question or a comment we really get often, that farmers cannot, they are illiterate. Most of them are illiterate. They can't really comprehend a graph. But that is not true, because I personally have had a first, and I think Nana Kofi has had the first-hand experience with farmers looking at some of these graphs as well. And the issue is that farmers, though may be literate, may be illiterate, they are very numerate. They are able to buy, sell stuff to you, give you the exact change and things like that. These things is to explain to them what each of the points are. And then counting is not a problem, because basically the reason why we show them these things is for them to be able to do counting and see the differences that they are. But usually we show them in this step, which is the step B, to see, like, to try and identify these situations, like, which year did you have the very bad year? Like you mentioned, maybe 83. This is Dodoma. Though Ghana was suffering in 83, it's like Dodoma was quite okay. You know, so those kind of things. Do you remember when like was a very good year, or you had a lot of rain? And then at that point, when they are able to see their experiences being reflected on the map, because we say maybe the high one means that's a very good one, and the very low one is a bad one per the product that we show them. And so once they're able to see these and it agrees with what they have experienced, they tend to have some faith in these graphs. And then sorry, who's on? Yeah, so this is not Ghana, sorry, this is Dodoma in Tanzania.
What is the season? What kind of seasonal rainfall levels? And the title does not define what system we are talking about.
Yes. So to Noma, I've not really worked too much there, but yes, but the season is asking the months, the period. Yeah, it's East Africa. Tanzania is East Africa. East Africa, it's I do not know. I won't want to this one, but it's their season. Their sister. I'll check it. Yeah. Okay. So good. Step C. So Maureen, I'll check that and let you know. But yeah, was there a specific reason why you wanted to know?
Yeah, because I think it's not for Ghana. It's someone to
the whole weekend. Yes. So that is clear. I think that's for presentation purposes. We didn't capture that one. Yeah. So then we come to the bit which is calculating risks with farmers. So this is what I was trying to do with you people a while ago with the variability thing. So, and again here, this varies. So this is seasonal rainfall totals. Remember what I was trying to do with you people was on the start of the rains and the end of the rains. So with the seasonal rainfall totals, you can see that here a farmer is maybe interested in a certain crop. Remember that every crop has different crop water requirements. Okay, so maybe let's say this is for maize. So maybe a farmer wants to know what are the chances that he probably will be doing well with a certain crop, which is maybe maize. And we know that maybe maize is, why do I lose this? We know that maize needs about 500 millimeters of rain to do well. So out of this number of years, it's about 80.
1930.
Yeah. Yeah, they have quite a very long record. So you count the number, they count the number of times they would have been successful. Again, you can see sometimes it's going down here, sometimes it's going up there, sometimes it's going down here. And this is a cyclic thing that comes with it. But the variability overall, so here, look at the 500 millimeters and they count the number of times they would have been successful. It's about 15 times they would have been successful to get 500 millimeters or more rainfall for that particular crop over the whole number of points there are. And that will give them, sorry? So I'm saying that 500 millimeters is maybe for a crop, maybe maize, okay? And then the account, I hope I'm not muted. Let me just, okay, good. Yeah, 500 millimeters is for maize. So they want to know what are their chances that they could get 500 millimeters or more rainfall for their crop to do well within the season, okay? And so here, what he does is to look at the whole period, puts like a ruler or cover the whole period on the 500 millimeter mark and count the number of times they would have been successful over that whole period, okay? And so here, when they do the count, which is 1, 2, 3, up to 15, over the whole like about 90 years, which gives them a nice close to about 1 in 6 years. Every 1 in 6 years, they will be successful in maybe growing maize in this particular point in the Dodoma. Okay, so that's
if you look at 1,
yeah,
11, and 8, they were considered, but you didn't consider between 5, 4, and 5. It's on the line.
Yeah, yeah. So I think that's just an oversight or something. Yeah. But and again, maybe it depends. Maybe you see this is like half. And this is something you are telling people you are better off to be more negative, and if it's positive, it's better than. No, this is not counted. This is not counted. This is counted. This is not counted.
It's not 8. That's 11. It's not 11.
Okay. So I think it's an oversight. Then let's just take it like that. Yeah. I think it's an oversight. Or maybe this is more
something close to 500.
Yeah, but I think it doesn't really. But you understand the whole process as to what's being done. So it's like 1 in 6 days, 6 years, you kind of will be successful in growing 500 millimeters of rainfall. Yeah, so these are some of the farmers trying to calculate their chances of growing a certain crop. So every farmer is what crop he or she is interested in. So after a training, they were trying to do their calculations whilst others looked on. This is a nice guy there. It's also, yeah, cool. Great. So aside the seasonal rainfall totals, we also share things on the dry spell length. So how long the longest dry spell within the season? How often do you get that kind of? Again, you see more variability being pronounced here than a clear instance of change. Good. This is also I'm trying to see, maybe this will help me find it before 16th of May. 20 millimeters. Okay. So I think their season is somewhere like between November and April. Okay. Between them is right. Okay. So, okay. Yes, that's it. Okay. So yeah, basically from this I can now see. All right, good. So again, you can see their start again, and you can see their end. Again, it's kind of similar to what we are seeing in Tamale, right? Yeah. And always you see that the end is almost always less variable as compared to the start. Yeah. Good. So again, that you can use the same procedure. That's what we used to. So and this is the length of the season, which is a normal subtraction. And you know the crop needs also the length, the crop water requirements, and the start to go. Yeah, so these are some examples of the probabilities that we share with the farmers. Okay, so there's a maize, which is like local, the variety is called local, and there's another maize called Pioneer XS. The days to maturity for local is 120. The days to maturity for Pioneer XX is 100. The crop water requirement for local is 480. For Pioneer is 350. The chance of sufficient rainfall if season starts on a certain date, which is an early date, is kind of being 5 out of 10. On a later date, because you kind of move into the season, you realize that it's 4 out of 10. On a late date, it's 2 out of 10. But for the same maize crop, but a different variety, you kind of see how increased your probabilities get. And that would be because of the amount of rainfall here and maybe the length of the season. It has a lower length and then a lower amount of rainfall amount. Okay. And so these are the probabilities, 7 out of 10. We try to put it out of 10 so that these farmers can relate to them. Good. Good. And then we start looking at the local options. This is, we try to make available to all the farmers within the group, the different options. So these are the options that we sometimes go with some of them, you know, as the extension officer will probably have some list of options, but the farmer are also kind of advised or encouraged to kind of, you know, bring also their options, which maybe they are trying, but the other farmers are not. And then we try to analyze them. Okay. And this is how we do the analysis. So here it's an example of a practice. So there's more about management options that we kind of look at. Okay. And for the crops. So here a farmer says he does ridging. Okay. Another farmer says he does composting. Another farmer says he plants strips. Another farmer says he tries a new variety of maize. Okay. And then you come to the who does it. This, we analyze it column-wise on the column basis. And then we have who does it. And here, actually, is the female, right?
Yeah.
Oh, a male has this.
Okay.
Right? A male has that.
So it's better this.
I don't know. Oh, I'm lying. Which one is male and female?
Yeah,
Sorry? No, it's that. I'm very sure.
You're right.
I'm right there. Yeah.
The bill is this.
Okay, good, guys. Let's continue. So yeah, the female does this, the ranging. Okay, both of the male and female benefits. And then we look here, what this column is guys, hello.
Yeah, please, you have a pointer.
Yeah, I'm using my mouse. Do you see it?
I'm not seeing it.
Oh, my brother.
Yeah, let's see.
I need a pointer.
On Zoom, eh? Okay. Okay, let me just try. Where's that? Apps or
No.
more?
There's no street in my top of
Just a minute. Fine. Okay. Okay.
Fine, if you're not
Surprise. Okay, so then try to see whether but I chose the pointer. Yeah. Okay, so there's that pointer. Yeah. Can you see it now? Okay, now so I don't need to go.
Fine. Can see.
Fine. Okay, good. Thanks. Okay, good. So you can see in this third column we have the performance. Okay, and then we have under performance we have 3 sessions. We have the low rainfall and the medium rainfall and high rainfall. So basically we are saying that in low rainfall, how does it the practice look like? Okay, or how does it improve? So here we have 3 options. We have the correct, or what we say the tick, which is means that it's done very well. And then we have the okay, meaning it's like normal, just okay. And then we have the cross, which is like it does very bad. So if we are looking at region, okay, in low rainfall, we say that's okay. Okay, in medium rainfall, it does very, very well. And this, remember, it's participatory. So we are kind of picking ideas and things from the farmers. Okay. In high rainfall, it does okay. Okay. And then we have in this column investments. How much is investment? The investment needed for a farmer to do this. Remember, we do these analysis because farmers' contexts are always different. They are not the same. Okay. Here, the options we have here are high, medium, and low. And then the variables we kind of look at are the time and then the money, the kwacha here. So the time for region, it takes a lot of time, which is high. For money, it's just low. You just need a whole, and then the rest is manpower. Okay. Time to start benefiting, maybe 4 months when your crop has grown. You should see a lot, quite good benefit out of it. Are there any risks or disadvantages? Said no disadvantages. Then here is the composting. The composting, you have again the females do most of the things. They do the composting here. Both male and female benefits. In low rainfall, it does okay. In medium rainfall, it does very well. In high rainfall, it does okay. Okay. And then the time is high because it takes a lot of time to do that. And then the money, you need medium money to do that. And it takes 6 months to kind of be useful already. Okay. The disadvantage is that you could have a goat kind of come and chew your stuff. And then here we have afforestation or planting trees. Again, females are mostly those who will be planting trees. You find the males playing dummy or something. Yeah, so, and then when the benefit is that you can get your crop, or depending on the kind of tree you planted, if it's share, you can maybe pluck some share and things like that, or you can make firewood out of it later, which also kind of goes to the family. And then you have performance in the low rainfall season. That's okay because the trees are there. Medium rainfall, it does quite okay. Like it does very well. High rainfall, it does very well. The time is high. In terms of money, you need medium money to need to buy the seedlings. And then it takes a longer time for you to see the benefits, about 3 years before you can see the benefit. Yeah, and the disadvantages is a lot of time, long time. Then finally, it is the variety. Both male and female can buy the variety. Okay, and then again, it has a shorter period of time for you to see the benefits coming up. Low rainfall, that's okay. High rain, medium and high, that's very well. Time is low. You just need to buy it, and this is part of your normal planting. And then you need a lot of money in terms of cash to do this. Okay, and time to start benefits is 4 months, and then you get a lot of money if it goes quickly and well. Good. This is another example for livestock. Okay, this is like going to, instead of keeping your sheep in the pen, as unlike leaving it for free range and going to cut straw for it to come and eat. Again, making bands of the leaves to be there, and then you go to feed. This is about getting drinking water for your animal and how that kind of affects. You can analyze it throughout here. And this is about inoculation, like injecting your fowls against coccidiosis. I remember when we were young, some of them, you see them walking on and then they die. So when you inject them, you kind of save your investment. Yeah, and then there's rabbits, okay? Rearing of rabbits. This is not a usual thing that a farmer would probably be doing, but it is an option that they've seen that can be also useful. So they kind of say so that in times when the season really don't go well, they can really rely on some of these things. And the disadvantage, as you can see here, is that they die quickly. I don't know those who have reared rabbits before, but that's what they kind of captured here. Sorry, it's true. Okay. So, and then this is also the livelihood. Remember, we talked about 3 options: crops, livestock, and livelihood. So making of pots is also another thing that they could be doing. Some farmers will not just be doing any other thing, but this gives them other. This is about laying bricks. This is about rearing of bees. You can see somebody's son. When you rear bees, you can get this one. I think this actually making logs to sell. And the disadvantage is that it causes this deforestation. Okay. The selling fishes. Okay, you make more money. That's the advantage. This one, I don't know. Going to fetch water or what? And then there's fishing. Okay, you make more money.
Why do you tell making more money at disadvantage?
No, sorry. So you need more money. More money. Sorry, yeah, you need more money to. Obviously, you need to get the boats to be able to go fishing. Yeah. Good. So the next thing is the participatory budget, which is the step D, step F, sorry, and step F already. Basically, what this is about is the farmer now at this point would have been able to make a choice as to what he wants to do, but he wants to look more into how much money that goes into the activity or enterprise that they choose, that they know whether they are doing it. So this, I think, is a mixed farm that they want to do a certain variety of things. And then in this column, they have in this row, you have activities, you have the inputs, you have the family labor, you have outputs, you have produce consumed, and you have cash balance or profit. And then these are the columns are the different time steps. Okay. So in the activity, the first activity is for him to kind of do break. Sorry. Yeah, in a sense, to prepare the land, including region and things like that. The second activity that's here is to, in the second period, he does planting of seed, and then I think, okay, in the third time steps, he goes to kind of do small weeding there, and then in the fourth step, maybe I should analyze it this way. But okay. So here, when he goes to plant and then apply fertilizer, he probably see the first planting, he needs 2 bags of seeds. Okay, and all of them will cost him 4 $4 or 4 dots. Okay. In the second one, they kind of get 2 bags of fertilizer, and then it costs them $6 or 6 dots. Okay. And then the family labor they need here is about just one person for 3 days in the first planting, and then they need another person for the second what they call it, activity of going to apply fertilizer. Okay, there's no output there, so totally it gets a negative cash balance of about the 4 plus the $6, which is about $10, a negative balance. Here, when he went to do the first reading, he hired labor for 3 days to support it. Okay, and that was $2, and that's the negative cash balance here. The third day he goes for the second reading. He kind of hires someone to go help him, and he pays $1 for that with one extra family member, and then gets a negative $1. Yeah. And there's a break, and then here he goes to harvest the green one. In the green one, when he goes, he takes one more labor to go with him and pays $1. Okay, and then the family another support for family, and then he tends to make about $6 from what he has harvested and takes one to the house to eat. Okay, and then he makes a positive of about 5. Okay, because this is 6 minus this one, so that's a $5. And then there's the last time where he goes to do the dry kind of harvest. Okay, and here there's an input of about 4 days labor. Okay, which costs $3, and then family for 4 days. And then he's able to get 90 times 5 kgs, okay, of maize, okay, and then that gives him about $16 as an output when he sells, and then takes one to the house, 190 kg to the house. Okay, when he subtracts the $3 from the 16, he gets that's about $13. Okay, and then based on this, he kind of now comes to sum up everything. Yeah. Okay, and so when he adds the 13 here plus the 5 here, which is going to be 18, and subtracts the 2 by 10, 13, and that's going to remain $5 here. So that's the last one. So here you probably be able to see whether this is a lucrative venture or not. Because if he actually is making minuses, then he or she will probably think about it, or whether this minus is good for the start and things like that.
So from this, we mean that you have take all the information from the farmer.
Yeah, the intermediary works with the farmer. Yeah, there's a lot of and this happens long before the season. So it's not normally, the farmers get busy when the season is about to start. So at that time when there's nothing, some people will just stay and not really be doing anything that much. So it's a good exercise for them to do. So basically, this is how the fixer whole process goes. You don't see my mouse again. Because it's visible. I'm moving around, but okay. Why is it slow? Okay, good. So the fixer has the long before the season bit, which I explained, include the historical climate information, plus the crop livestock, all of that in the first page. Okay, so as you can see, this is slow now. Why the battery is dead. Still slow. Can you see? What's the internet? Just a minute. It's like the that's fine. My internet, yes. Owner. Okay, good. So here is a long before the season period, okay, which I had explained. And then we said just before the season, there's a seasonal forecast and we revise plans. And then there's a during the season where you go and give them information to change anything that's okay. And then there's shortly after the season where you review the weather forecast and process. Okay. Next. Yes, so I'll just give an example of the possible climate services or projects that people will normally usually run. Okay, they normally will start with the National Met Service as a key partner, and the National Met Service remain in what we call their comfort zone, okay, which is to maybe they remain in their comfort zone and then say, well, we can give you forecasts, we can give you short-term forecasts, and maybe a 10-day bulletin thing. And maybe they say add some automatic weather stations to the project for them. You know, so but here we kind of say that we start with NMS as the National Meteorology Service as a key partner, emphasize to them the demand side, that this is what the farmers are looking for. When do their rain start? Are the dry spells getting longer? How long is the season? Okay. And then we kind of do that whole Pixar activity within the long season before the season period. Okay. And then in the process, we use extensive use of their historical data. Okay. Daily records are really needed and useful for this activity. And we normally encourage that the Met services themselves are those who do or generate these products, okay, as we've done in the past. We also emphasize the options by context, which I had already talked about, as opposed to fixed recommendations. Okay. The livelihoods and livestock options, not just only crops. We introduce farmers to livelihood and livestock options, as you have seen in the previous presentation. Okay, and then like I told you, in 2015, we kind of engaged with the Ghana Met Service in the north of Ghana to do Pixar with other partners in Adra and Oxfam. Okay, and we were able to visit 10 districts in northern Ghana. We visited about 140 communities. There are 6,000 farmers which were reached. 60% of these farmers were male farmers. About 40% of them were. Yeah. Good. And you can see these are some results from the evaluation of the Pixar process. Okay, in Ghana, Malawi, Tanzania, Rwanda. You can see that for most of these places, the percentages are very high, like making changes in crops, livestock as a result of the Pixar process. In Ghana, where we had about 416 as our sample size, we have 97% of these farmers saying that they had made a change because of Pixar. Okay. You can see that also in Malawi. In Tanzania, you can see that there's about 52% here, which has been one of our very lowest scores. Okay, and this is because the Tanzania Met are people who like get lots of projects, and so they get so busy with so many things that they are not able to concentrate as much as they would do in they should be doing for a certain project. And we think that's one of the things which have contributed as compared to the other countries that this has done. Okay. So these are some of the changes that the farmers said they had done. I grew a new variety of crop or a new or different crop. Okay, about 20% of those who said they had made changes said they had done this. I grew a new or different variety. About close to 40% of them said they had done that. I changed the way I manage my land or crops. Also close to about 30% said they had. So these are examples of things that farmers had done. And these are examples of changes that some of the farmers make. And these people were people I met personally. And this lady said she had started a small business of selling soya beans because of the Pixar celebrations and things that they had done with them. And this is because she realized that farming alone was not enough. So what she decided to do was, in the previous season, she went around to buy the soya beans from the other farmers and then went to store it and then waited for the lean season and then sold it. Okay, so and this is because of the ideas that we had brought to them. This other farmer said he started engaging in the short-term variety because he didn't want to be caught up in the whether the season is long enough or not enough, because he saw that the season was quite very variable. So he decided to go into a certain variety of cowpea in addition to his staple crop that he kind of grows. And the short variety of cowpea takes about 54 days to do well. Okay. So as at the time I had visited to kind of talk or interact with them, he had already harvested one part of the cowpea and had grown another one because the season was still ongoing. And so he thought it was an interesting thing to find by looking at how variable the graph was for the start of for the length of the season. Okay, and this farmer said he had started going to a new livelihood because of the information we had brought them. Say they should be exploring not just only crops but also other livelihood activities would be good. And his livelihood came up as a result of what he thought his other farmer colleagues were doing. So he studied and realized that most of the farmers would decide that, well, I'm going to farm on 10 acres of land this year, and I'm going to get a lot of. They go and weed the farm and everything like that. In the process of just finishing, or maybe one time they are going to plant or something, they go to the farm and they go and get a snake bite, or they go and step on a scorpion, or maybe they go and get pricked by a thorn, and that'll keep them home for about a week or two, and then the farm suffers. So he decided he was going to make ties, which he would sell at a good cost or a low cost so he could encourage his other farmers to buy these. At least it reduces their risk of having to stay home for a very long while. And so he made some more money from it than just to support his crop. Yeah, so these are some of the stories that we got from there. And these are changes that farmers have done. This is a male farmer from northern region in Ghana. And there's this female as well, which is quite an interesting thing from Malawi. So she changed her early maturing maize. He changed to early maturing maize and used conservation farming techniques. He said after a difficult season, she was able to harvest whilst others weren't because of what she had done. Okay, and this helped her pay her daughter's school fees, fed extended family members, and bought seeds for the coming season, including hoping to try new crops in the following season. So these are some of the success stories that we came across with Pixar. Okay, so yeah, just to put into perspective some of the tailored products we had shown you earlier in the lecture. You have a question? No? Yeah, which one? The sketches? I don't know. Some of them are not Ghanaian ones. Others were done by. So I think what they did, what the guys, hello. What the extension officers would do is to draw the framework. John, you asked a question. So what they do is to draw the framework, and then the farmers are those who kind of input or the designs itself. I don't know. Sometimes I think in one of my visits in this process, you find out maybe when like I said, if there are males and females, the male will probably say, you do it, like the lady should do it. There are sometimes where like maybe their children also come to those meetings. So some of them are going to schools and things like that. They can also kind of start to draw. So most of it is difficult for them to hold the pen because it's their first time sometimes holding a pen. So you need a lot of encouragement to talk to them. I've been to, which country was that? Was in Mozambique in one of the situations, in one of the visits there. What they did was to use some of the things they could. So if like he's going to go corn, she probably would bring like a corn hacks to come and represent that this is corn for him. If it's the drawing, is going to be a bit this one. But yeah, they kind of have the ideas on things. The last column. This one. It's a goat. Goats will chew there. Yes. Yes. The compost. Nice. Any comments on this? So that's Pixar, which we did in 2015. The only bad side of this for me has been the fact that it has died down. Like since 2015. So we did in 2015, 2016, we went again. But with 2016, I think we had, in 2015, we had ADRA and Oxfam. In 2016, CARE also joined, CARE organization also joined. And then in 2017, since I think 2017, we tried, but since then, it has not gone off again because of, I think, funding.
Is it something that you would expect the technological education to take over?
So the let me see if Roger is back here.
Of course, it's something which is very beneficial. We can give annual reports to the ministry.
Yeah, so
it's the project that is ongoing every time. You see the impact.
Yeah.
You get it. So now we're going to slides what's the name? R-Instat, and these are not the very good products. So if everybody can do it, GMet, and we can now do it over and then do it something.
Yes. So the issue I think was that we thought this was, and some of the extension officers have the training of these things. And this is not just a one-person thing. We see it as a collaborative work between the agricultural department, the Ministry of Agriculture and GMet, okay? Because you are going to provide the products that the farmers will probably need. But it's not originally your job. You can maybe on one of occasions to pass by. Their work as MOFA to support these farmers. And so more of a collaborative thing. So if there's a way where GMet could kind of make a case to MOFA, and instead of just concentrating on airports, it's a way to also.
The challenge is, the MOFA, we were originally using the PSC approach.
Okay.
What is this?
That is what I think that
participatory scenario planning.
It is slightly different from the Pixar. The Pixar is not comprehensive because it brings in the historical element, those other things. So some of the districts adopted, the
PSV.
Exactly. So it's just about a day event or something, a day or two, and it's off. So maybe
has there been any kind of like report or something like the way Pixar has like? So this is published, like the 2015 work has been published. And so is there like a report or anything like that for PSP? And there are trails to to see some of the successes that Pixar chopped in Ghana as in 2015, you know. And there were questions which were asked. So as a farmer, you've received Pixar. Did you share the tool or what you learned with them? And so from what we had done, so we have reached about 6,000 farmers. But out of the farmers that we spoke to, they say that, well, on the average, they had reached about, I think, one farmer had reached about 5 people about the procedure or the approach, implying that it is even maybe more than the number of people we had dealt with directly. You know, indirectly, maybe you get it times the 6,000 could always be close to about 30,000.
Just one. So not use one for.
Sorry?
Multiply by 6.
Why do we normally do sample?
Yeah, but you just go how many? It's an average by
5. Yeah.
No, an
Average. So there are some people who spoke with more than 5 people in there. Yeah.
Okay.
Yeah. So yeah, that's yeah. It's just unfortunate that it has not been continued. And this is all only happened in the north of Ghana. There are other parts of the country which can also gain.
Oh.
The sample that the population that we had reached directly were about 6,000 farmers. And then the sample sample in our case, the sample has got to do with, it's a random sampling thing that was done, okay? But random with communities. So all the communities that we kind of engaged, we got samples from those communities to ask them questions about the approach. We state the samples that we used. The total 6,000 people. So that is the sample. 416. Yes. 97%. We said they had made a change. Yes. There are so many. There are so yeah. They are. You have the point, but there are constraints. You cannot. Sometimes you can always use a sample to talk about a population. So far as your sampling technique was well done. Like in our case, we thought we had used the best of sample techniques. We can always use that to talk about the population, because getting to the whole population has lots of constraints in terms of time, in terms of like the funding to even be able to go from one person to the other or one community to the other to get this kind of information is not an easy task. This is what happened again. So there were, aside the communities that were sampled, okay? So the communities how many communities did I say we went? 140 communities. We had gone to a sample of them, okay? But we made sure that every district had a representation in our sample, okay? There were 10 districts, but so all the 10 districts had representation in our sample. And when I go to a community, which was then the next level of sampling, okay? I don't go and I've not selected the people I want to talk to already. I go there and get all the people out of the community out, or who have been like engaged in the, how they call it, in the training, in the Pixar training, and they come. And when they come, you then That's where we do our random sampling, best, like just use Excel to kind of random, given the numbers that you are giving each and every one of them. So those who are up to the number that you wanted per community, and the community also was done in such a way that if you have a very big community, you take lots more people from there. If you have smaller community, you take lesser number of people. So you do not know who you are going to talk to until you are there. You understand? So we think, and I think for you can always use a sample to talk about something. So first, it's clear. I understand when you say like 416 is quite small out of. Yeah.
It's more than 5%.
Yeah. Is it that is me? I think Maureen is very soft spoken. It would be nice to hear you like you. She's very, her points are very like hitting, but they are spoken like very small and you get to like but yeah. Let me could you please? I think I have an ear problem. But it's not me. Okay, then please, I think. Yeah. For the Met people. So I was not the finance person in the project. I don't think Roger wasn't the one on the gang in Ghana. It was Graham. Sorry.
You went on some field trips, right?
Yeah.
So you see yourself as an advisor, professor who was going through those, like what?
That sometimes I didn't go alone. I gone with the team. So I go with some people from Met. Yes. Sometimes we fly, right?
Yes.
Sometimes. Yeah, I think there was one occasion where I went with Kofi in a car. And because there was flights were delayed. So it wasn't only just me and Kofi. It was Graham and then Peter as well. Yeah. That first one. And they took pictures of us sleeping in the car like us. Yeah. But yeah, it can be expensive. Sort of. But again, that's where the outstation things work. So if your outstations, I think it was Seacrafts. Seacrafts is the money.
I think supported by
yeah, Adra had committed a bit of it. And then Oxfam took care of their costs. So Oxfam were paying for their volunteers or local NGOs which were involved.
And that is also part of the costs.
Yes, it's also part because so it can be like GMet needs to probably you can do what you can do, but that's why I said I think it is supposed to be a collaboration between GMet and the Ministry of Agriculture. You understand? So if the leaders or the big shots can discuss this as something that can be done, you already have what they call it extension officers in North or in places. You also have outstations there. Is there a way you can kind of involve the outstation, maybe for a training on some of how to generate some of these things, or can generate with them? Because we've kind of, there was this guy when we were going, we kind of engaged the outstations people. What's his name? That was very interesting for Met services. Okay. And we know how the wind blows kind of It's got to do with the wind direction and the speed that the wind is kind of moving with. Before I do that, I just want to give this simple exercise. What we think is the mean of 10 plus 20. So if, no, 10 and 20 I meant. So if like there's a wind blowing at maybe 10 degrees, okay, I don't know how you call it, 10 degrees, maybe if we are using the whole thing, that's 360, so 10 degrees. And then another wind blowing at 20 degrees. Okay, what's the yes, so the north, right? So 10 degrees and 30 degrees. What's the mean or the average? What will be there? Sorry?
10 and 30.
15.
10 and 30.
Yes.
10 and 20.
10 and 30.
10.
That'll be what?
20.
20. Okay. So are we sure that's the, as I'm saying, we are looking at it in terms of the wind.
Yes.
Are we sure?
All of them between them. It's
varies.
this one is here, this one is so it's very
Okay. So what then becomes the mean for 350 and then 10 degrees and 10 degrees.
Yeah.
Also,
350 and 10.
yeah.
Yeah, 360, yeah.
To be 360. Is that really?
What? Because you see, the camera points are 360. 10.
Well, guys, let's speak one at a time. Let's remember that they are.
south.
I'm coming. Guys, hello. So because there are other people online as well. So let's try when you are speaking. You want to speak?
I'm saying that when you say camera point,
Yeah.
360.
Did you get my question? My question is just as you calculated 10 and 30, and you gave me the mean to be 20. What is the mean for wind that's blowing from?
If you calculate it, assuming this 360.
No, well, okay, yes, go ahead. Guys, someone is speaking there.
80, 180, 90, and 270.
Yes.
So
350.
Somewhere here.
Yeah.
10 somewhere here.
Yes.
So give us 60. Now take it.
Show me how you calculated that.
Why should I? Because you are trying to build the wind going from the 3.
So what is the formula? That's what I'm asking. You are showing me something practical, but so it's 10 plus 350 divided by 2, right? Just like you did there. 10 plus. Why does it not work that way?
So,
Yeah.
that's what I'm
So
Why does it not work that way? That's my question.
he's asking
I said I want the mean of 350 degrees and 10 degrees. It's 360. It's 360. How many people think it's 360?
But if you add 350 and then with 360, divided by 2 will give you 180. That's the different direction altogether.
yeah.
Okay, sorry, there's
minus 20 plus 20.
yeah.
You get minus 20 plus 20. So minus 20 becomes 340. Plus 20 becomes 3. So that range 4 within the law.
Yeah, I agree, but you are showing me something practical here.
Yes.
And I'm asking, why is the answer 360? Why is it not 180? Like the way you simply did it.
No, that one you want that one.
Why?
But there was 10 and 10.
No, At 3 minutes.
If we're not adding that, it's very often.
There's someone wanting to speak here.
Okay, Francis.
Hi.
Okay, from my experience,
From your experience, there's something speaking.
you are saying 350 and 350 and let's say 10 degrees. Okay, what I get from this is that the wind is varying.
Let's
From 360, 350 to 10 degrees. Okay, which is an indication that the winds are coming in are northerly winds. So should I take a mean of 10 plus 350? It's going to give me southerly winds. So the wind direction is going to change.
I understand that. So I'm saying that why is it going to be like that?
Why is it going to be like 180?
Why are you saying it is in the middle, the zero mark, the 360 zero mark?
The main flow.
Because I'm looking at the direction that the wind is veering. So if it is, let's say 350 and 10, I am having 20 in between the two, okay? From 350 to 360. And I'm having from 360, which is 00 to 10. I'm having 20. 20 divided by 2 will give me 10.
Okay.
So the 10 plus the 350 is going to give me northerly winds, 360.
Yes.
So it doesn't have to be the 350 plus 10 divided by 2, which is going to change the direction of the wind entirely to southerly.
Great. Yeah. So I think you still have the point. Actually, the answer maybe I was trying to look at this to say that this is because this is a circular data, and that's also kind of leads into the idea of circular. So after 360, it's not linear. It doesn't continue. It comes back to that. So yeah. So it's in between. It's either 360 or the zero mark, depending on the yeah. Hi, Roger. I see you just joined. Would you want to make any comment on this, or we go ahead?
No, I'm happy to make a comment. I noticed, for instance, at salt ponds, you measure the data every 3 hours. I saw your 3-hour data, and that includes the instantaneous wind direction in degrees. And now I'm curious that I don't know how the salt pond data on a daily basis, how do you calculate the average wind direction on a daily basis when you've got 8 measurements round the circle? I think that's roughly what Francis is trying to get to, that it's all well and good, and you're absolutely right that the circular mean of 350 and 10 is either north or 360, namely north. But you do need to have a formula, because just as when you measure instantaneous, you do want to have the average wind direction over the day. And you can't use the ordinary formulae. So I wonder what GMet is doing currently to get daily and monthly summaries of wind direction. I wonder, they must be using something, or else I don't know whether Clyde Data uses something. Does it use special formulae, or does it get the answer wrong? Does it get 180? So I am interested to know what GMet is doing to go from the 3-hour data to the daily data for wind direction to get the mean. So so that's, I think, the question Francis was also asking in a slightly different way. I think there's an interesting question there, because the whole statistics is different. And the corollary to this is that when I talk to Met services and say, what do you need for your statistics? They say windroses. And I'm very happy with windroses, but circular data is very common in climatology. It can be the wind direction, It can be the time of year of thunderstorms. It can be the time of day when it starts to rain. There's a lot of things in climatology that are circular, and it's really rather special from that point of view. And therefore, it's interesting to me that almost nobody has studied how to take the mean of circular data or the median, or what does it mean to be halfway up the data when your data go round a circle? And what about the spread? What does the standard deviation? There is a circular standard deviation, but the linear standard deviation can be any positive number. The circular standard deviation is rather interesting because you can't go very far away before you come round again. So there is an interesting subject there, which is almost unknown by Met people, except they're obsessed by windroses. Now we're going to do windroses, but I'm very happy that France is trying to introduce this aspect in a slightly more general context. I hope that helps.
Yeah. Roger, thanks. So one of the questions I think Roger was asking, which I would want to re-echo, and if you have an answer to it before we go into demonstrating how you could make windroses. Let's do. Sorry.
Yeah, Francis Thomas. Mr. Adam can speak to that because he has been generating the windroses for the marine space from our end. So I think he can give you some information. He's around.
Okay. Mr. Adam, they said you can give us information how you calculate like the wind for the average wind for a day. Yeah, what software do you use? Yeah, but what's packaged in R?
Is there, so the more you get a record, then the speed, you just make it.
Yeah, no, it means like the average. So you kind of measure them on 3-hour basis. Let me just try and see if I can show you.
And the observers
You have it on 3 hours. Okay. So what do you use for your day? How do you get the average wind speed on a day?
The site, now everything is
Okay. Use what? What's the NCL? Okay. To do that, I go to file. I want to use a data set from a package called Open Air. Okay. This 7.5. So I import from library. And then I load from, I hope I'm okay. I load from R and the package in R. So basically, I'm understanding when I was asking about the packages for every function, unless it's not the base, unless it's a base thing, that's for every function thing that you do in R, you need some package to form. You need a package which hosts the function that you are going to use to generating that. That's why I was asking what package you use in generating that the windows that you are talking about. But for this, we use Open Air. So you see, I type O and then I have Open Air. Okay, and so I'm going to choose the my data. Okay, that's an example here. Okay, and you can see I've read the data now. You can see it measures wind speed, wind direction, measures something on nitrogen, O3. What's the name? Is that how's it called? No, not O3. O2 is oxygen. O3 is. Sir? Hey. And then SO2 is sulfur dioxide. Okay, yeah. And then CO, carbon monoxide, and then yeah. So there, it's kind of helps with like doing analysis on pollution and things like that. This data set has that. Do you people measure things like that? Do you measure O2? You don't have instruments. You do measure. Okay, so you have data sets on that, like your personal. Okay, so how do you measure? Do you have instruments? You have in your house. You have an instrument. Eh? Or you have a space in GMet where it would be good for us to know, to have that data set to see how polluted GMet is or Accra is or your house is. Okay, good. But yeah, this is an example of data which measures those things. Okay. And so you can see the date variable here. Okay. It's having the year, the month, the day, and also the time. Okay. So every hour this is measured. Okay. Sorry. No, I picked it from Open Air. The Open Air package is
inside the R.
Yes, yes. So after lunch, Roger will do that. Which one? The data. Okay. So please, you go to file. I'm just reloading the data again. You go to file, you import from library, okay? And then you come here from package. Okay, when you come to this package, there's this R help function here. It tells you a bit about the package, okay? When you click on it, it gives you information about the package. So it tells you that the my data set is provided as an example data set, blah, blah, blah. Okay, you don't need internet for this. It just opens for you. It tells you a bit about the observation, wind speed, wind direction from north as a numeric vector. NOx is oxides of nitrogen concentration in PV. NO2 is nitrogen dioxide. Guys, hello. Are we paying attention, or if you want to just eat, we can just stop so that we. No, but you are talking. You are not. How do you eat when you talk? Okay, so O3 ozone concentration, yeah, and then P10 is PM fraction measurement of blah blah. But it gives you the help gives you information about the data set that you are, and you don't need internet for that. Okay. I'm going to click that. But yeah, I chose my data. Okay, and then I go okay. Okay, and then it reads in the data set. Okay, that's my data. And then I open here just to show you the dates. Okay, you can see the elements. Okay, and so here before we were dealing with things on days. Okay, elements on days. But this time we are dealing with on the row we have hours. Okay, so hour information and it's hours per hour. Per hour. So, and then on the again, you can see how tidy this data is as you go across the columns. Yeah, you can see the different elements that describe that particular. Sorry. So I go again one more time, guys. Please pay attention. You go to File, Import from Library. You come to From Package. Make sure you are choosing Load from R, not Load from Instat. Load from R because it's the R one. And then you type Open, Open, and then you should open Air, and then you choose that one. There's only one data set in that package, which is the My Data. Okay, you click on it, and then you okay. Are we good? Yes. Okay. And that opens it. But I just was trying to let you see a bit about how the data comes in. Okay, so we can see the year, month, and day, and then we see the time that it was recorded. So I say every row is an hour information of maybe wind speed, wind direction, okay, onwards. Okay, and so I was saying that this shows how tidy the data is, because we on the row we have an hour information, and then as you go by column, you find things on attributes of that particular hour, okay, or parameters related to that hour. So you have the wind speed, you have the wind direction, you have the nitrogen oxide, or I don't know, and all the rest. If you read the help, it will give you information about the different elements. Okay, so in this, trying to analyze with this in this stage could be a bit worrisome. We can easily get the, what do you call it, how do I say, the dates out of this. I'm going to show you how you can do this. I don't know the climatic facility for doing that, but I probably would just go to prepare, okay, and then I'll go to column text, okay, then I'll say I want to split, okay, because basically we want to split the days from the time, okay, and then I want to say I want to split it into text components, okay, so I just leave it as it is. I select my data too, okay, and then I choose dates. That's the column to split, into the column to split, okay, and then I say you should separate it. You should look at that and separate it by the space, okay. You should look at that column and look for a space between. I'm seeing between the one and the time. I see there's a space, so I want to say you should separate by the space. So I put space, and I say you should split into fixed number of components. The number of pieces it should return is 2, which is the date and the time, okay. And so I just do that, and I say I want to put it close to dates, okay. I want to put, there was split which was here, so I'm gonna split originally was there. So I go to position, then I want to put it close to dates, okay. After dates, okay. Then I return, then I go to okay. Good. So we have it split now. You can see the dates, and then you can see the time in one column, okay. And so you can rename it if you want. No, before I even rename, what I'll do is I'll go back to prepare, and I want to use date, and I want to make a date, okay. And I'm using a single column to make the dates, okay. Which single column is that? I'm using the split, the first split as a date. I leave it as default format, and then the name will come up here as date 1, okay, already here. So I just sorry. Yeah, I should have done it that way. I should have brought it back. It's here. It's on the last bit, but let me just. Yeah, that's what I want to do. So let me move this. Okay, good. Okay, cool. Good. So I now have the dates. It's now a dates column because you have D there. Okay. Before it was a character thing because I separated them. Okay, but now I have it as a date. Good. And then I can decide to use it. If I go to my climatic, I go to dates, use dates. I can get my year information, get my abbreviation, get what again do I get the day in here. Okay, and then let me go. Okay. Okay, I have that split now. Okay. You get it? Yeah. Okay. So good. Let me just go straight to this. now, and then I want to go back to describe, okay, and then I want to use the wind speed, okay. I want to generate windrows.
Sorry.
Yeah, okay. Yeah, I hope we are following. Good. The what?
So, just next.
You go to prepare, or you can be in climatic. Dates, make dates. Okay, then single column. It's already highlighted. And then you choose the dates you want to make, the column you want to make dates. And obviously the split first one, not the one with one. The one with one is the time. So split and then default format and do okay. And that should give you the date. Are we good? Sorry? The time. So I think currently the dates facility doesn't have a time element yet.
So she's saying the time over the hourly. Yeah, all right. But you can split.
So I think for that, you just leave it as it is now. I don't think that element is currently. You would see. Let's go into the analysis, guys. We have another thing we want to do, the satellite thing. So if we don't finish, we probably wouldn't speak. So back to climatic, describe wind speed or direction, windrows, okay? And then I come here and then I choose my wind speed is WS, my wind direction is WD. And then I don't want to facet anything yet. Let's just see what happens. I do okay. Then this is my plot, okay? Generally, we've been having more winds in the southwestern area, okay? And their speed is also kind of, we have more about just about 8% of it being what they call it, just about between not 0.4 and not that between 0 and 4.03. Okay, the scala. And then we have this other percentage here, being that of that one. Okay, you can also have this. Let's see if we wanted to see it by year, like. It's facet by
Right?
Yeah.
The result was 0.4.
Not 0.40, between 0 and 4.03. Number of columns, number of columns, 1, 2, 3, 4. I'm sure you can. Windows options. I don't know about that. The colors. Okay, let's see if this works. Okay. And let me see if I can change that one to 4.
You have the chance to find the news speed range.
I'm sure you have. Yeah, you would have that. Let me see. So if you go here, I want to have 4. And then we get the winds. I can't wait. Okay. Yeah, I think this bit you can do that first. Okay. Yeah, so you see, I just changed the.
Wait.
It's going. Yeah,
So it's,
per month. Yes. So January shows where a lot of winds are. Okay. But this kind of resonates with the general one, which was showing that most of the wind was in the southwest area. So yeah, that's also another facility that to be at your disposal. Okay, I think that's all I want to show you now.
You say this.
So I'm assuming that my task is a simple exercise to set the scene for the way in which I think we could easily compare satellite data with station data. I want to do a small exercise with you. I'm going to use, is that correct?
Yes, Roger.
Okay, so I'm going to share my screen. Oh, that's the wrong R-Instat. I'm going to go into R-Instat. This exercise is using the library data, and I think it would be, if you wish, I could go at the speed so we could do it together, if you think that's a good idea.
Yes, Roger.
Okay, so I'm having a new data set and I'm going to import from the library from the Instat collection. I'm going reasonably quickly because I think this is all very familiar now, but slow me down if I'm going too fast. So I'm from the Instat collection, I'm browsed, I'm climatic, and I'm Tanzania. You'll see why it's Tanzania in a minute. And I'm taking the Dodoma file. I'm assuming you can do that. I'll just check quickly, you don't need to copy this, that it is climatic. So these data are defined as climatic. You don't need to do that. So I'm happy with these data. Okay, is everybody there now with a set of station data? And in the station data, there are sunshine hours. And I'll go to the bottom. And at the bottom here, you can see I have some data on sunshine hours. Okay, you're welcome to be trying to keep up, or if you find it easier, just watching. So SUNH is the sunshine hours from the station. I'm now going to go to File, Import and Tidy a NetCDF file. So I think we'd like to bring this into the standard importing, but currently it's a separate importing file for NetCDF. The file's with the NC extension. And I'm going to take some data from the library. And if you're following me on your machine, you should have 4 data files. They're basically radiation and sunshine duration. I'm going to use SDU, which is the sunshine duration, which is produced by UMetsat. And you see this is an NC file. Am I okay to open it?
Yeah.
Okay, I come into here and there's quite a big file name. I don't mind that. And I could just press OK straight away, but I like to show you some options because this is a very powerful facility for reading and tidying NC files. So you don't need to do this yourself. There's nothing much to do, but in these options here, you can have a range. Of course, my range is very simple. It's just a single point. So my longitude and latitude are just a single point, but they might be more. And you can now choose the range. So if you've got a very big file, you could now choose to enter just a smaller range. You could choose to locate a single point, which of course I've got, or you could locate the points in the NC file that are the same points as you've got for your stations. So if you've got a station file, you can try and match it up and get the similar points from the NC file to link up with your station. And I think that's what it would be good to do in Ghana, where you've got maybe 20 stations and you could try and import the data for those 20 points. And I'm going to return here and just not change anything. But I'm giving you the impression there is a file. There's a powerful facility here. And I then want to say, okay. And I have imported the file and reshaped it nicely. So it's looking like an ordinary file. And here is SDU, the sunshine duration from the satellite, and in hours straight away. And so 5.7 hours, it thinks, was the first observation, which was the 1st of January, 1983, at the same point for Dodoma. So it's the same longitude and latitude. So this is the estimate from the satellite. And in Dodoma, I've got the data. I now need to merge the two. And you'll notice I have a date file and a date time file. So I'm going to go to prepare and data frame and merge, add merge columns. I want to add a column into my station, which gives you the sunshine duration from the satellite. So if you're ready, here I go. So this is the satellite, and I want to take that data and put it in the station. So I'm going to take data from the satellite and add it to the data frame for the station. And all I want is the SDU. And because the name is the same, it is proposing to merge using the date. To merge by, which is exactly what I want. So I click OK. And when I click OK, I'm put back to Dodoma. There is the sunshine hours, and there's the sunshine duration from the satellite. Aha, that was easy. I hope you're getting the impression that this is part of the idea of R-Instat, of really making it easy to do things that in the past took quite a lot of time and expertise. That's the whole idea of writing this front end for R-Instat. Okay. Now I've got my two columns. I've, in a sense, ready to go. I just want to see how these columns compare. Before I do that, it's quite useful, as usual, to examine. So I'll do one variable summarize. I'm in Dodoma. I'll do my usual, add all, and then summarize. Oh, here I might put this up to 12 because I've got the months. And here I've got my data. And the months are there. There's the sunshine hours from the station, and there's the sunshine hours from the satellite. And you notice that I've got a lot of missing values, but I have got 10,000 values that are the same. I notice that I'm not going to do this, but it's not silly to do quality control on the sunshine hours, which we haven't done yet, although the data look quite sensible. However, I'm a bit nervous about the 14 hours here. Oh, I can't do it like that. Can you see the maximum for the sunshine hours for the station is 14? And 14 is quite long for Dodoma for the day length. The maximum day length is really more like 12.5 hours. So there is a value which is slightly suspect from the station. And if that's suspect, then 16 hours is quite odd from the satellite. I wonder how the satellite gets 16 hours. And I've written to the people who produce the estimates. They're busy looking at whether their algorithm can be improved. And so the point I make is that quality control, just because the data come from the satellite, doesn't mean there's no quality control to do. By the way, when you don't need to do this, but just watch. Here I have the data for the satellite. And this is the record just for the times the satellite are there. I'm going to quickly go back and do one variable summarize for the satellite data. Add all and OK. And there's the information for the satellite data. And you'll notice that the period of the satellite is, where's it gone? The period of the satellite is 1983, 1st of January, to the end of 2015. The period for the station for the sunshine is about 1974 to 2013. So they overlap quite a lot, which is good, but the satellite goes to 2015, whereas the station, when we got the data, stopped in 2013. And there's not many missing values for the satellite, but there are a few. And these were in the early years, mainly, before 94, when they changed the satellite. And remember that the satellite is just, it's measuring radiation. And what's exciting about satellite data is that it's an instrument, and these data have been standardized and homogenized, etc. And it's using a single instrument, but it is using an instrument. Now you use a different instrument for each station. So you've got to be very careful with your instruments to make sure they're measuring exactly what you want. And it's very nice that this uses just a single instrument from the satellite, but it is just an instrument. And so it can go wrong in the same way as other instruments can go wrong. Well, let me come back to my Dodoma. I'm now ready to compare sunshine hours with SDU. Now, that's very simple. How do I compare two columns of data? Well, I think some of you will say, oh, we do correlations. Okay, let's start and do correlations. And in the climatic menu, we're quite pleased with this. There's more to be done, but we've taken some of the general dialogues and put them in here. We have a whole set of things to enable you to compare quite simply. And there's lots you can do here. And I think this is really important to do very carefully. So I'm going to start and just show you a few of them. It may be the next 15 minutes. And this would be quite an easy exercise for you to, I could just take two columns because I've just got two. The first column is sunshine hours from the station, and the second is SDU. Before I find the value of the correlation, I'm going to have an option here, and I'm going to do a scatter matrix. And you'll see why in a minute. So I've taken the option, and in the option, I'm going, instead of not having a graph, I'm going to have a graph, and the graph is a scatter matrix. Okay, I'm going to press return. And then I'm going to say, okay. So I'm just going to get the correlation coefficients with a graph. Aha, I have my graph. Let's have a look at it. I can make it bigger. And I hope you're impressed. It's not perfect, but it's looking pretty good. So let's have a look. The correlation is nearly 0.9. Here's the scatter plot. And you can see that the sunshine hours go across here for the station, and the satellite goes here. Now, initially, you should be very happy, and then you see there's a few days you might like to examine which are slightly puzzling. So most of the data go in a nice one-to-one line, and that's already very exciting. I hope you agree it's exciting. But there are a few values here. So what are the values here? These are values where the sunshine is 0. There was no sun at the station. But the satellite here said there was more than 10 hours of sunshine. I wonder what, I would still like to examine that. It could be, we don't get the opposite here. There's no values the other way around. But here there are not many values, but some. And there, of course, the correlation would be even higher if we didn't have those. So just because the correlation is high doesn't stop you examining the data. So I'd like to examine the data, not now, but if we were doing a more serious study, even though it's looking great, I still would like to understand those days. When do they occur? And is this because in the station I accidentally had zeros and actually it was missing? Or are they real zeros? Was there actually no sunshine and yet the satellite said it thought there was more than 10 hours? Even though it's just a few days, I'd like to understand them. and quite a lot of days with 5 hours from the satellite and nothing from the station. So I would like to know what's going on when they're different. There's quite a lot of differences this way round, and there's other few differences, not so many the other way round. When the sunshine hours were quite high and the satellite said low. Now, the lower the correlation, the more problems, the more there's to examine. The other thing that should excite you is if I was using the sunshine data and finding, this is like a histogram, it's a density plot. And you can see the density plot has a peak of just over 10, and it's quite sharp, and it goes like that. And you should be amazed, this is then SDU, and it looks very similar. This is tremendously exciting. Of course, this goes to 16 because of that one observation, and this only goes to 14. But you should look at that and say, that's fantastic. I wonder if we get the same for Ghana, because if we do, then I wonder if we could use the satellite data. It's looking pretty good. Now, and the correlation is pretty high, nearly 0.9. And then you should reflect and say, is this too simple? And what's too simple about it? Well, let's have a look again. Here's the data. I'm going to go back to my dialogue. And remember that we have time series. These aren't just two columns of numbers, they are time series. And time series have a periodicity. They have the seasonality. So if you think of a time series, you can think of the trend and the seasonality. We've ignored that completely. I'm still going to ignore the trend, but I shouldn't ignore the seasonality. It's not so great in Tanzania because it's closer to the equator. It's more important still for Ghana to understand the seasonality. So I'm going to come back to the options here, and I'm going to add the month into it. So I'm now going to look at it separately for each month. And it was too simplistic to just say these are two columns. I want to now think of them as two columns, but separately for each month. Remember, I've got 10,000 days on which I've measured the sunshine data. There's lots of gaps. Nevertheless, I've got 10,000 days on which to compare. And so now I'm going to do the same thing, but taking into account the months. Now, that's quite interesting. I noticed that in the rainy period, the correlations are very high, 0.92, 0.9. And here, I think that's 0.88, and that's 0.92. So that is December, November, December, January, February, March. The rainy period, the correlations are very high. They're not so high in the dry season. And now we see that the shape, it's still looking pretty good, but it's getting confusing because they're all there together. So I think I want to look separately at these months, because you can see the histograms or density plots are very different shapes in some months. So here, these months, which are the dry season, are we're getting a lot of sunshine. Whereas the rainy season, sometimes we don't have so much sunshine, and sometimes we have a lot. So I think I want to look more carefully at the data split up by the months before I write my article and say, yes, it's all right. By the way, I also, I only have this one station from Tanzania. If the stations from Ghana are as good as this, that's a very important set of results. But I only have one station from Tanzania, whereas you've got data for quite a lot of stations from Ghana. I wonder if the results are anywhere near as good as this. So I'm now going to come back and argue that I'll look at something else. I'll come back to my compare. Let's be simple. I'll do scatter plots. I want to do scatter plots of, which way round shall I do it? SDU on the Y, that's the, no, I think I'll do the sunshine duration, what I've observed as the Y, which I'm going to estimate, if you like, by the X. And by the way, I will do that as a plot option. And I want to do it by facets because I've realized the months are important. So I'm going to do it by month. Remember, this is what's so nice about our, I think I'll have this just to make it nice and colorful, and I'll have the months there as well. I think that will just make it colorful. Let's check. And I'm going to say, okay. That's quite nice and colorful. And now I will have a look at that. Oh, it's gone. Where are you? Here you are. And I'll make it the full screen. Aha. Now I understand also a bit about why the correlations are higher in the rainy season. Can you see in the rainy season, sometimes you get zeros. That's November, and here's December, and here's January, and here's February, and here's March, and that's the rainy season. And then it goes from 0 to quite high. And remember, January is also, December, January is the summer because we're in the Southern Hemisphere. Whereas I notice in the dry season, it's almost always sunny, so the range isn't so great. There's a few days like that, but there's also some odd values to investigate. But I can't expect such high correlation when I don't have the same range of data. The correlation has its limits, and we're seeing the limits here. And we also see some of the outliers in this relationship, which I'd like to investigate separately. One can look at, these are individual days. It would be nice to look at those and see what's happening here. So these are the outliers in 2 dimensions. But generally, you can see the important things here. And by the way, it's more important in these months because in these months, I've got quite a lot of sunshine anyway. So I don't have so much to estimate. I know it's going to be pretty sunny because there's no rain. This is very much the dry season. So from May, June, July, August, September, October, you don't really get rain. The rainy season is November through to April. So that's quite interesting, and that's quite nice to do. I wish we had a simple system to add the correlations onto this graph, and that's the next thing we're trying to do. So we want to be able to put the summary statistics on these graphs as well, and that's the next thing we're adding in our simple system. So that looked quite good. I wonder what the density looks like. So I'm going to go back to climatic and compare, and I'm going to do a density plot. And here's a density plot. You can see there's more things you can do, but I'm just going to finish with this density plot, and not a histogram, a density. And I'm going to take the single variable. Well, actually, I'm not. Here I'm going to have to do a little trick. I'm going to do the plot options first and include the facets with the abbreviated month and return. And now I don't want a single variable in my density. I would like to have 2 variables. I'd like the sunshine hours and the SDU together. And I'm going to say, okay. Then I'll have a look at this. Now, I hope you can see these graphs. The red is the actual data, the sunshine hours, and the sort of greeny color is the sunshine duration from the satellite. Now you can see they're not the same. In March, it looks very, very similar. Oh, what's happened? Oi. Oh. Curious. I've lost it. Wow. That's very odd. So I'm going to quickly get it back. And I don't quite know. So you have to amuse yourselves now because I'm going to have to start again. But I'd like to continue to show you that. So I'm going to go through it. I don't know quite why that happened, what I must have clicked on. But I did want to show you the punchline. You almost saw it, namely just how closely those were related. So that's one of them. So you're getting the bonus now of having it done a second time. And I hope it doesn't collapse again. That's not happened to me before. And now I'm preparing data frame, merging the columns. And I merge the columns onto Dodoma. And I'm adding SDU. And I'm going to say OK. And I'm then going to go climatic, compare, density plot. And the plot options. Oh, let me return. Density ridges, plot options, include facets of month and multiple variables and sunshine and SDU and say OK. And I'm now going to look in here. And I'm going to do this. And now I'm comparing the two. And I claim that they look pretty similar. So similar that in Dodoma, I feel, remember the saying, you know, all models are wrong. So using the satellite instead of the station isn't the same, but some of them can be useful. I would declare that this looks, you know, there's very few practical decisions that you would make with the actual sunshine hours where you'd get a different decision if you used the satellite. Now, I don't know if this is the same in other places in Tanzania. But remember, the satellite information on sunshine hours is every 5 kilometers. So this is like having 400 stations measuring sunshine hours with almost no missing values for every square degree. So that's well over 4,000 stations in Ghana. So you've got more than 10 degrees. I forget, have you got 20 square degrees, 4 by 5? So it's maybe 8,000 stations measuring sound, if it works as well as this. Now, this is astonishingly good. And so I've never seen satellite or reanalysis data that's as good as this. Don't expect it to be as good in your country, in Gambia or Ghana, and don't expect it to be as good for other elements. But it gives you an idea of two things. The first is the actual steps to compare have become very easy with R-Instat, because we've got this menu. And the implications of it, if you can use the satellite data or reanalysis data, are just very profound. We could be using the satellite data. Remember, they're like another station. So we could use them to do quality control. That's one very good use. So we could be checking on the quality. If we had an odd value from the station, what did the satellite say? We could use it to infill. So instead of infilling, just guessing the value, we could infill using this new, in quote, station. And if it works really well, maybe we could use the satellite data where we don't even have a station. That's like the ultimate infilling of where the actual missing was everywhere. So we just use the satellite. As I say, I think this is astonishing, but I hope you're impressed how easy it is and how much work you could be doing. I have to say that the important variable is rainfall, and rainfall is one of the hardest variables to estimate. But there are satellite estimates and reanalysis estimates for a lot of the elements. How exciting is that? I finished.
Thanks, Roger. Thanks for the demonstration.
Okay, I'm sorry it broke down. I don't know how, but in a sense, you got a revision because of that. And I'm sort of passing it over to you. There could be a bit of discussion, and happy to answer questions. I think this whole area is huge. My concern in this area is, and that one of the big reasons we've constructed R-Instat and are giving it away to you, is that I am concerned that the people who are producing the merged data and doing the work are not in Africa, and you're having to use it. And I would like to see a lot of this work done in Africa. So I'd like to see some PhDs and some general work by Met services, not just using merged data, but using it with knowledge that it actually is very helpful and is improving the data you can provide for your country.
Yes. Roger.
Okay, over to you.
Thanks, Roger. Any questions, comments? Those who are so keen on using NetCDF files. Do you have any questions or comments? Yes, please. Do you have the? Can you speak in?
I'll speak louder.
Okay.
Roger, please, can you hear me?
I can hear you.
All right. So my question is, we were using the sunshine hours recorded locally in Tanzania, and we use the one provided by the satellite in the form of NetCDF.
Yep.
Now, if I want to use that of temperature or any other parameter, and I want to compare, you know, the example you gave was directly inside R. Am I right?
Yep.
Yes. So trying to do enough of comparison to be able to see how well these various NetCDF files from the satellites are compared with our station data. I'm accessing or probably getting these various type of data that are available. You know, the one you have provided was directly in R-Instat.
Yep.
Yeah. So I'm just wondering, in terms of using your own downloaded format, how it could be like.
Okay. Let me try and give some answers anyway. You're absolutely right. We made it easy for ourselves and for you in the way those data were provided in the library. but let me come specifically. There's different sources of data. Let me take temperature. With temperature, the UMETSAT, and we've written up how to import the data in chapter 9 of the climatic guide. And as you have correctly queried, it's not really quite as easy as that. But the satellite does provide temperature. And however, when we first looked at temperature, temperature isn't provided for max and min from the satellite. It's provided on an hourly basis, just the temperatures. So you would read in the hourly temperature data, and then it isn't actually the max and min from the same, it's ground temperature, which might be different. But so there could be a bias there. However, it's still, you can get the daily max and min. And so there's a bit more of a step to do. The second problem with the practical things there are that from UMETSAT, unless the UMETSAT people are kind to you, as they were to us, they provide the data spatially rather than temporally. So if you want to have data for the whole record, you ask for the daily data, but for the whole period. And that works fine, except I'm going to share my screen again. When I import and tidy the netcdf file, instead of browsing a file, you have to browse for a folder. Because when you download the data for an area...
Roger, are you sharing the screen?
Oh, I'm not. I should. Just a minute. Thanks, Francis. I'm back on my import netcdf here. File, import and tidy netcdf. If you get your temperature data from UMETSAT, you tend to get a file per day for an area. Not as we've shown here, a file per point. So the data are laid out the other way. So if you want 30 years of data, you get 11,000 files. Now, we've tried to make that easy, but you would browse the folder and it would then collect together the data for that area, for those 11,000, from those 11,000 files. And then you would have to choose the points from those files that correspond to your stations. So the importing, this actually isn't difficult, but it's not as easy as I've made out here. And as I say, the UMETSAT, it's not, it's ground temperature on an hourly basis. So once you've got it in, it's not a question just of merging. You'll have to calculate the max over the 24 hours and the min over the 24 hours to approximate the max and min temperature, if that's what you're trying to estimate. Now, there are different sources for temperature, and some of you may have used chirps. Have you used chirps? CHIRPS. Chirps is one of the standard methods for estimating precipitation. That's the P in chirps. Well, now there is also CHIRTS with a T for temperature. And that's quite a convenient way of getting the temperature data on the same scale. So instead of using UMETSAT's data, you could try the CHIRTS data. We're quite excited by the potential of that. I have to say, I noticed from the CHIRPS point of view, and you might check with them, that they get excited if you're willing to share your data with them. And I notice for your precipitation, you share a lot of your data with them. I'm not sure whether you've shared the temperature data with them. And if you did, you might get them to do some free work for you where they're using your station temperature and Church is trying to get the blended product. And so it might be in your interest, and we can liaise with you to share the temperature data with the Chirps people, the same people as the Chirps, but with a T, Chirps, and use those data to be estimating the temperatures. So that's among the things to do. The other data that we find very exciting is the ERA 5 data. So if you take the important elements, they include the sunshine hours or the radiation, which comes from UMETSAT, the rainfall and the temperatures. Possibly you could try using Chirps and Chirps for those. And then wind speed and wind direction and other elements, you could use ERA 5. ERA 5 has the big advantage over almost everything else. It's hourly data with no missing values, and it goes back to 1950, and soon it'll go back to 1940. But it has the disadvantage that it's on a bigger scale. So it's 0.25 of a degree rather than 0.05 of a degree. So the pixel size is considerably bigger, and but we've got to check. But it's got every element you can imagine. So it's got the temperature data as well, and so you can check. And this is what the exercise should be. Not saying I'm going to merge, but there's lots of different candidates. The Japanese produce a system, and so on. So, but ECMWF we found with ERA 5, it takes some beating, but it's quite a bit of work. I would like to see in your 2-year proposal that you're going to want to do quite a lot of work on this to be able to supply blended data when it's appropriate, and also a critical review, so you don't apply it when it's not appropriate. And linking up with the universities, and maybe it's your own people that are doing MScs. There's John is going to be doing his PhD in this area. That's one reason we were keen he joined you. But there's plenty of space for more MSc and PhD projects on this. There's quite a lot of time and work needed, but it's exciting work. And we hope R-Instat will have a contribution to helping to make you very much more productive than you would be otherwise. I don't know if that answers your question or just carries on a lecture from my point of view.
Well,
Thank you.
Great. Any further comments or queries? Cool. Are we good?
Yes.
Okay, Roger, thank you so much. I think that's really been
Thank you very much. I'm going to leave. I'm looking forward to your review. I was really delighted with your contributions on the Moodle site with your ideas. I'm going to leave you to carry on with the other components of what I hope is an exciting last day for you. And I hope you feel, as I think your director was hinting, that this is the last day of the beginning rather than the last day of this. It's the last day of this workshop, but it's the last day of a fruitful beginning of your use of the software and an exciting collaboration. And I have to say, I was delighted that it's involving Gambia as well as Ghana, and hope that collaboration can continue as well. These are very exciting times. I hope you agree.
Yes, Roger.
Okay, I'll leave you to it.
Yeah, cheers, thanks.
Bye.
Thanks. Okay, so there are two things I think we need to do before we close today. The first thing is to continue with the discussions. There have been new things that you've been shown today. I don't know whether you want to get into your groups again to amend some of the things you would have learned today, and see how that goes into the kind of proposal or something like that. maybe in the long run, we probably want to have all of these kind of compiled to help those who are going to like lead these proposals, give them some ideas to what they should be fleshing, out of the points that we as groups have put on the Moodle site. Does that help? And before we do that, I'll quickly want to show you how we could. Sorry, I just want to see this message. Sorry. Yeah, sorry. So I wanted to show you how you could kind of, for instance, the issue we had this morning with when we started working on the start of the rates. Okay, if you have certain issues, things you are like very sure, because I was certain that this should work. I didn't understand why it wasn't working. And I would also kind of encourage that anytime there is always from time to time, they kind of update their software. Okay, very soon, I'm sure we'll get 0.7.6. Okay, and so when you download, and that's what I've done, I always try to make sure I have like at least 2 old versions on there, and then there's a new one. Okay, because when you just delete the old one, what happens is when you go back to the site to download to want to download the old one, you don't get it because it just put on the newest version. Okay, and so I'm just going to show you how you could maybe put in like what we call an issue. Okay, if it's like a bad report, or probably you were doing something and you thought, it would have been nice if we had this like a new feature. So yesterday on the missing values, there was a point where Nana Kofi was we were able to make did you post it? Okay, good. So I don't know whether maybe you show it even, but basically he found something on the missing value, and the missing values, how you deal with them, and he thought, well, maybe I want missing values within certain months. If there are missing values of a certain degree in certain months, then ignore, give me back a missing value for everything. But if they are not, then give me the value. So that kind of thing was not, when he looked at the options, he didn't see that. So he thought and wrote to the group and said, well, this is what I have seen about missing values, but could you please give me this other feature, because I want to be doing this kind of things. The team would assess what you are thinking. If there's another way of doing what you are doing in another dialogue, something, they will point you to that, or they will take that into consideration and see whether they kind of add that in the new version. If it is something which will be useful, not just for you, but for a group of people, that will be considered and put in. So I want to show you how we do that thing. I don't know if Derek is gonna do that, or I should do it. So what I do is you just go here and GitHub. How many of us are on GitHub?
Sorry, Francis, do you want to show your screen?
Okay, sorry. Okay. How many of us are on GitHub? Derek, find the name for me and the name of the Insta one. Yes, sir. How many of us are on GitHub? Okay, if you are not, then it would be a good place to sorry, not active yet. Maybe R-Instat will get you active. So when you go to GitHub, it says GitHub login. Okay. Click on that. I think my name is this. I have an account already, so I'm just filling in. If you don't have an account, what you can do is to click on create an account. Okay, when you click create an account, it tells you welcome to GitHub. Let's begin the adventure. Enter your email. So you enter f.torgor@aims.edu.gh. Okay. You say so. He said email is invalid or already taken. So I've already created that. So it's not going to allow me. If there's someone who wants me to register him or her and use him as an example, that would be good. I don't know. Is there anybody? You. Okay. Please, what's your email address? APULLOLMET @gmail.com. It still says that email is invalid already taken.
Check your email.
Maybe you have already sign up for. You've also done it. No, so okay, then I'll just go on to show you if you have an account, what happens if nobody is willing to sign up for that. Okay, so if you sign up and everything, it sends email and it creates the account for you. When you sign in, you come to sign in. Just put in my password now. I hope I remember my password. Really? I'm sure this is not me. So now I'll sign in, and I'm even already on here. This is the different repositories that I've joined or have used. Okay, and I mean the team of the African Maths Initiative, R-Instat group. If not, what you can do when you get here is to search. So when you are searching, you can search for African, okay, Maths Initiative, okay, and you can put the /R-Instat, okay. Then we just go enter. Okay, immediately it opens for repository results. Okay, there's African Maths Initiative R-Instat. There's African Maths Initiative R-Instat Help. There's African Maths Initiative R-Instat Data. There's African Maths Initiative R-Instat Translation. Remember on the first day when I was speaking with you guys, I showed you the different translations that were going on. There's the medium in which they used to put their translations and things together, I think. This is also for data. The R-Instat, I think the data library and things, this is a group what they do. And then there's for help. There's for those who develop the documents and things that are used in R-Instat. Okay, and this I think covers all of R-Instat. So, and it's more for the programmers, those writing the programs. Yeah. So I come here, and this is what you want. You want to come here. Okay. And then you would want to go to issues. Okay, you look at there's code, there's issues, there's pull requests and everything like that. What you have is an issue. You have an issue to pick with them. So you come to issue. And then under issue, you have what's that? These are all issues I have. Where's that one? Sorry. Good. So there's a new issue here. Okay. You see, I hope we are all paying attention. It's very important. When otherwise, if I'm there and you call me and there's a bug error, I also don't know what to do. I'm showing you what you should do, then we can help from there. Okay. If it's just a normal code problem, the normal, like I've forgotten how to do this, fine. But if like there's a bug and I'm not too much into this, I will not be able to help. Okay. So this is how we get our help. You come to new issue. You click on new issue. Okay, then there are two types of issues you can make. A bug report. I think what we had this morning was a bug report. And then there's the second one, which is what? Feature request. Okay, which is like what Nana Poku was doing yesterday, because he saw something, thought, oh, I wish it would have done this way or done that way. Okay, and so he made that request. Again, there could be a feature request you could make from the weather reports thing. You could make it also using this medium rather than just speaking to one person. When you do it here, all the group of developers tend to see what's happened or what's happened. And so if one of them is not has not got the time to look at it, another person would have the time to speak with one person, and then that's if he doesn't have the time, he doesn't get to do it. Okay. So I'll just go through them, for example, for you. So let's get started with the bug report, like today. So the title, let's just use what happened this morning. Rain, start of rains. Start of rains, dialogue, gave an error saying call, saying call name not found. Okay. And now you want to write. Here you write, and it has some. If you want to preview it, if we want to preview what is already written here, we can see it here. So this is what it tells us. It said first one, we are supposed to describe the bug. Okay. And then here you are supposed to give a clear and concise description of what the bug is. If your description is not clear and concise, they will not understand what you are writing and will not do anything about it. And then 2, there's another heading to say to reproduce. So what is the steps and steps? What did you do to get that error? So steps to reproduce the behavior you are calling the bugs. Okay. And then expected behavior. Expected behavior is to see basically a clear and concise description of what you expected to happen. I expected to find the rows or column of the years and the different stats under the different years. Okay, but I didn't see that. I rather saw, and then screenshots, if applicable, add screenshots to help explain your problem, particularly of error messages. So I took a quick screenshot of the error message. Did you already make an issue? You've already made an issue there. Okay, good. So that I don't need to make again. So basically, you can put that screenshot there. And then the R script or commands that were related to this issue, you put that also there. So remember that when you go into R-Instat, okay, and for anything you do, what is this? Let's see. I want to just show you something here. Stay off here. What did I do? No. So when I wanted to put tamale, okay, you see it's ready. Then it's kind of open the script window for me. Okay. So if I do not want to, and this happens when you want to edit what what the default or normal output would be. You want to edit it slightly because you know a bit of programming. You come here to script. You click on to script, and then you get the script. Okay. I'll come pull this down a bit. You get the script, the whole script. So you copy this, okay? Because it is after that point when I click OK that I get that error. So you go through the whole process again. Don't click OK, just go to the to script, okay? And then come and copy this code, okay? Right click, copy, okay? Then you go back to your issue that you're trying to make, okay? And then you paste it there. Remember here, you can't type here. This is just a preview, okay? But you can type in that bit, which I'll show you right after here. So then you paste it there. And then the details again, to ask you what operating system are you using? You should know the operating system. I'm using Windows 11, so I tap Windows 11. Which Instat version are you using? 0.7.5. Then you put it there. Then if there's any additional context, anything you probably want to do, you could write here. For instance, because we had the older version, which was the 0.7.4, we took the code, and I think Derek was doing that. He said, when I looked at both codes that I was getting, both scripts that I was getting, I realized that the 0.75 is the same as the one that 0.74 was giving me. So I didn't know why there was an error. So this kind of helps them. If you have any additional context, you could add to that. When you are done, you just submit new issue, and that's it. Okay. But you write here. This is just a preview. So if you want to do any edits and everything like that, it happens here. This is where you can delete what the concise whatever blah 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 is, you know, and then make those issues. And then after that, submit new issue, and then that's done. The team would really be excited if you guys could be using the GitHub to report most of your bugs. They will not see it as something which is negative. It's rather something positive to improve what is being done. Remember, they may not have the time to test everything, every facility on there. So it would be good if you test and you see an error. It doesn't mean the software won't work again. It's just something which can even, I think, sometimes do have some bugs, some of the packages. I know Happy has even mentioned saying some things were bugs of the previous one and now they've corrected and things like that. So this is not a bad thing. If you find something doesn't work well, sometimes it could not give you an error, but you see that you're expecting that 1 + 1 should give you 2, and then it's giving you 3. It is something which you can talk about. It may just be the code problem or something. Okay, does that help? Yeah. Okay, so if you are on GitHub, this should be an easy way for you. All right. Given Derek has already made this, I'm not going to make the issue again. African Maths Initiative. So I'll put it here. I can try and put it on maybe the Moodle site. Okay, so if there should be a procedure for, no, I mean a procedure for making issues. If we have a document on that could be put on the Moodle site, so that if some people have, they could just go there. Do you people have something like that developed? Okay, you can find out in the later. Please, we'll put it up on the Moodle site. Okay, just for. I think it's probably even there. I doubt it. Absolutely. Do you know if that is?
Sorry?
Do you know if there's like, yeah, there is. So for feature requests, and thank you, Anseli, I've already seen it. Thank you. So it says that for feature requests, if you go to the Moodle site, it says for feature requests and for embargo reports, post as an issue on our GitHub site. Okay, so when you click here, it should take you directly there. Okay, that's if you are registered. If not, it would ask you to create an account and all of that, and then you should be here. Okay, but I think it would be good if we develop a document to show how this works. Yeah, so maybe discuss with the team. Yes, basically, I think that's what I want. The last thing I wanted to show, in case you had that issue and things like that. Okay. And the reason why I was saying that it would be good to keep the old version is that sometimes when you've used the old version for a while, you actually know there may be improvements in the new one, which are not in the old version, but you kind of know the things that are working and you've been using it for a while. So at least keep it a bit so you are very familiar with the new version. The new version shouldn't change that much, but it's always a good thing to do, right? That's if you have space. If not, it's okay. So I'm sure they would work on this bag, and then hopefully you can download the newest version. Okay. Cool. I think that's all I have. If we can just go quickly into our group before DG comes here, and I heard DG is coming to close the session. Are you going to check on him? If we can go into our groups to finally have the final discussions on what has been learned today and put it up. Today is Friday.
Now, it's a good idea for us to get it done. Because the time is coming.
He's coming. Okay. All right. So please, let's just quickly get into our groups and then see whether we would add something on the things that we already discussed previously. Thank you. Yes, I'll do that. But let's do the discussion. It's the last thing. The weather report. Those who are really interested, I'll wait to. When did you finish?
Let me first listen to some of the participants, their impression so far. And let me start from my friends from Gambia. You have been flown far away from Gambia to Ghana Meteorological Agency for this 5 days training program. What do you have to tell us? What is your view so far of the program? And what do you think we can also do better to improve a program like this going forward?
Good afternoon, Director General, Ghana Meteorological Agency. Good afternoon, my colleagues. Good afternoon, my boys from Gambia, my team, Wana and this is a very good, it's a good day and it's a great day for us to witness the closing ceremony of this very important topic. We are really grateful for the Ghana Meteorological Agency, and we have really benefited from this training. This training will go a long way to help us improve in our services. So what we feel for the Director General is for the collaboration to continue, because we have learned some new things here, but we did not complete all what we are supposed to do. And there is one we are supposed to do. We will definitely want the support of the facilitators and the Ghana Met agency, which is the tightening of the Gambia data, so that we will be at the same level with the rest of the group. We are really grateful and thankful to the Ghana Meteorological Agency, particularly the director. On behalf of the Minister, the Director General of the Department, and the entire staff, we are really grateful and thankful to all of you. And we thank Roger and Francis for organizing such a program. And we hope this is not going to be the end. And we are appealing to them also to make sure we have certain regarding the duration of the training being short. So we will appeal to them to look after, to see whether they can source funding from somewhere so that we can continue the training. Because the training, once we go further, that means we are going to explore all the facilities within the R-Instat so that we'll be able to apply them within the system. On behalf of the team that I came with, the Director General of the Gambia Department of Water Resources, under which the Met Department is, and our Minister, I thank you very much, and I say goodbye. We are happy because we are treated here by hope, so we do not have any issues here. So thank you very much.
You rise every day for 5 days, and that's okay for you. That's fine. Thank you, brothers from Gambia. Thank God that for all this period, there hasn't been any cause of concern, any major complaint from any one of you, and I believe things have been smooth, as we have just said. Can I get one hour to make a yeah, feel free. I want to hear you.
Director General. It's just a matter of adding one or two things. You all are the same from the same country. I want to take this opportunity to first of all thank the director and his team for accepting us in this particular training. The training which is come at a better time. It's very, very good to us because this will enable us to forge ahead in order to develop our data management system. So without wasting more time, I think my colleagues have said a lot. I will thank the Director General and his team for once again giving us a room to witness this important occasion. On that note, with the name of my director, back to Banjul and Honorable Minister, and your humble self, I thank you very much for giving us the opportunity to be here to share this important thing. I thank you very much for your kind attention.
Yeah, hello. So also on behalf of the Ghana team, we'd like to thank the organizing committee and then to our management for collaborating to bring this training on board. To some people, some of the things treated may not be too new. They've learned them in other packages. But I've seen, or we've seen that R-Instat also has some good packages that will enhance, especially how to add comments directly into your data set, not that you have to wait and maybe move to another, maybe Excel or Word document to be able to do that. That was very great. Another aspect that we've also been all introduced to was the Pixar, which also has been another interesting session that we have had in addition to all the other packages we've been introduced to. So we're looking forward to use this tool very much to improve our work, and then we are hopeful to keep in touch for any further collaboration or anything that we need. If we also identify anything that we will wish for it to be incorporated into this tool, we are about ready to share that. And then we're also grateful for the team that they're also about ready to support us at any time we call them. Another thanks to our Gambia colleagues who have also come. We've also learned something new also from them as well. Interaction and other things has been very grateful. Not just that, has also created another form of networking, whereby we can collaborate more, not only for this R-Instat, but we can go beyond this platform. So it's been a great session, and we are looking forward for more collaboration and continue to become a role model to other Met institutions across Africa. Thank you.
Mr. Potofi, we're asking if you probably wanted to say something too.
Yeah, thank you, Francis. And 5 days, I just come like an hour, and I believe our colleagues and myself, once we are enjoying, it's very sad that it's coming to an end. But whatever goes up might surely come down. And I will say very thank you to you yourself, my professor, and the team from UK, not forgetting the Gambians who also came, and then we've learned new things from them and had interaction with them. And also let me go to my Director General for multi this program. We thank him very much. But what I can say is that, yes, new packages have been learned. And the only way to sustain it is more practicing. So I would challenge the climate session, the hydro session, the basic network, and the forecasting session should take those packages that are useful for them and start looking at how best we can improve on our service delivery. It's very, very important. And I believe some of them will help us very well to forecast and tailor-made products for our clients in a very good style. Thank you very much. And I wish the Gambian safe journey back home. And all of us, to my colleagues also, because today I realized that lunch did not come very early, but because they were enjoying the stuff, they were not complaining, and they contributed to the success of this workshop. On that note, I wish everybody a very good weekend. Thank you.
Thank you, Mr. Potter. Yeah. Over to you. Okay, Prof. Lamte is also going to add a few words.
Okay, so good evening, everyone. Now, what I wanted to hear, everybody has been thanking everybody, so the thank you is okay, right? Yeah. So what I wanted to hear, Potiphar started it, but he didn't put the whole thing. He was mentioning, he was picking some sections and saying he wants to see the climate there. We want to see everybody, not the climate, not the hydro alone. The regional offices, when you go, the first thing is everybody should have a local version of the software on the computer. You have been sending data to headquarters every month. Start using that data. This whole method thing we are talking about is data manipulation. Any information you need comes from the data. You have to process the data into information. So we need to have the skill to process the data. And you've gotten this. Don't go and sit down and say, Director General, we don't have computer. If you are serious, you will find some computer. When we were here, look, we go some old computers, but we'll go out and go and find it to do, right? So please, as you are going, the data manipulation is key. I will give you an assignment. Every month, the data you are sending, compile it, analyze 4 variables, write it into a report. I will take it. From every region, not climate and forecasting alone, all the regions. So you are generating a state of the climate for your region. And every month you update it. By the time the year ends, you have the annual state of the climate for your region. So everybody should do that as you go. Thank you very much. Another point, form a network of this thing. Don't go away and use WhatsApp alone. Form a network where you are going to exchange ideas on R-Instat. When you can't do something, ask somebody on the platform and they will show you what to do and use it to improve yourself. Thank you.
Thank you very much, bro. I think you said it all. This morning I met the participants in our office coming from the retail levels. And I just as Prof said, I said that don't think you have come, you are the region because you're not having a central analysis forecast office in your region. You are waiting for Kafu, for Agro, Hydro, Glamu. We are working in such a way that at some point you should be able to log into a system and have access to our data and be able to extract the data covering your area or some station you are interested in and be able to analyze it. You don't have to wait for that because Prof are giving you an assignment that you bring data to us every month, analyze that data and generate product out of it with the training that we have had. And that is wonderful. I think if you take it up, it will help us. You only know by doing it. After learning this, if you don't put it into practice, 5 months down the line, you have challenge in getting back to it. And so please, I believe, listening to all of you, the objective that we set for ourselves, if we haven't done at least 100%, we have got a pass mark of over 50%. I believe there's still opportunity or room for improvements. And as my brothers from Gambia said, opportunity for us to do more. I believe you all agree with them that we need to do more. There are areas that we have been introduced to for the first time that we need more in-depth knowledge and skills there. And then there are areas that will call for expansion. In fact, one of our objectives is to use this as a platform, identifying some areas to be able to come out with some proposal to ensure that we institutionalized our Instat software in our operations. And so by and large, we have achieved most of the objectives that we set for ourselves. At least we've been introduced to staging, graded, and satellite data manipulation. I believe there's more work to be done there. And then quality controlling of our meteorological data. This software is going to help us do that. And this training has sharpened our skills to be able to do that the more. And then the issue of identifying potential areas for going to developing a long-term program or project, look for funding and then pursue it as was strongly suggested by our Gambian delegation. And so I will thank IDEM as an innovation in development, education, and mathematical science, Roger and the team for facilitating this workshop, giving us this training, and all the supports far away from UK and Francis here, has taken us through for this week. Again, special thanks goes to our UK Mets, and especially Karen and Marcot for the support he gave it to us for us to get our Gambians down and for us to have this wonderful training. And then to our staff, meteorologists, who have, spent all these 5 years from morning till evening every day. And I mean, active participation in the program is very encouraging, but I will implore all of you to not make it just an event, but go back and let's use it and let us reflect in our operations. And let us move away from dealing with raw data to process data. If if somebody comes to you at the regional level and is looking for data, find out from the person what is going to use that data for, and then with these skills, be able to generate a product, a service to the person, and to give raw data. And that's what we are aiming at. That GMet will not continue dealing with giving raw data, and then when we are participating in projects and programs, or what the project leads and are looking for from us is, can we have this data? Can we have this data? What do they need the data for? And this skills is what we need for us to process this data to be able to provide necessary products to serve the teaming supporters or clientele that we have. And so thanks everyone. Thank you, my brothers from Gambia. Tomorrow, God willing, you probably see your family back at home. And thank God that He has brought you peacefully, and then He will send you home peacefully. I'm greeting to my friend Pierre Lamen for allowing you to come and be part of this program. Thank you to everyone. And as I said, I believe this training and the skills we have learned is going to be part of our SOPs and is going to guide our influence or enhance our service delivery. Let it reflect so that the resources that Roger, UK Met, Karen and co, and all of us have put together to make this a success will be beneficial to the end user, who is an ordinary man on the street out there, a farmer in his farm out there. So that will be relevant to society. On that note, let me thank everyone, and is Roger on? If you have something to tell us, Roger.
Sorry, I thought you were doing so well. I have very little more to add. I very much enjoyed the week with you, even though I've joined you from afar. And I have to say that I think you're fast on the way to becoming a really exemplary Met service. The ease with which we were able to use data, we've never before had a workshop where each of the groups used different sets of data. And the enthusiasm and the ease with which they practiced showed that you're already setting an example to many other countries. And as I've mentioned, this is, I hope, just a beginning. I've very much appreciated that we've worked as a team on the resource side. Francis, thank you very much for your hard work. And John and Al-Haji and Amsaleh. I'd like to mention just one success story that I think is happening in Africa. Many years ago, we started with a project, or Africa started with a project called AIMS, the African Institute of Mathematical Sciences. And you now have at least 3 graduates of AIMS that are providing their little contribution. So Amsaleh is one of the stars of AIMS. Francis was the first year of AIMS in Ghana. Al-Haji was from AIMS. AIMS is having a little bit of a supporting role and helping the Met service. And as I say, the dream that we have is that many Met services are very good at servicing the airports. They're very good at forecasting. Can they be equally adept at making all these wonderful uses of their climatic records? And when you've spent as long as I have on developing Instat and R-Instat, it gives me immense pleasure to just see the enthusiasm with which now people are adopting and using it, and how it can really help, not just you, but for you, as I think you were saying, Director, to help your country. So I don't want to spend too long, but it's been a great week for me. I've enjoyed it thoroughly. And I hope this is just not the end. It's the end of the workshop, but it's the end of the beginning. And I look forward to the middle and further work. And thank you all very much.
It's the usual thing of us. Immediately we get to our home, that is it. Yeah, so in monitoring, I'm just wondering how we can really do this one.
The model site is also there.
The point is as to whether we are going to go back to the model site and then do it. That's the question.
And that's how you're going to generate the report. You don't even have the report. Every reading is supposed to generate report every month.
Okay. So in monitoring, seeking, make a seeing traders is done.
Yeah.
Yes, that is my question. If somebody doesn't do it, then what happens? If somebody chooses not to do it.
The headquarters, what about the different departments? What are you also going to do?
We are expected to do it. Okay, we were put into different groups, 4 groups. So out of these 4 groups, then we can now equally divide the various stations to each other. But American will provide all the data. Then we can work on it. No. Then we can produce reports.
Or I get a report for this program and the recommendations. Okay, so you must get a report. This. All right.
Okay.
So let's go to what the point that's one of those things. And then we don't use it. I don't think it will reflect in our work. So as we have said, that's an area that we just introduced, an area that is one new area that we new way spoken about it as you have to take it on board. Only have the connection to
Link with the